Hey guys, welcome to the live session on Apache Spark full course by Intellipaat. This session is conducted by multiple experts who will be teaching you all about Apache Spark from scratch to advanced level. But before we begin the session, make sure to hit the subscribe button and also hit on the bell icon so that you will never miss an update from us. Now let's see the agenda. Firstly, we will begin with introduction to Apache Spark. Then later on, we will learn about Spark streaming. Then after that, we will explain you about Spark RDD and Spark DataFrame concepts. Post that, we will be doing a hands-on project on how to use Spark for accessing data files. Then later on, we will see what are the companies who are using Spark and how businesses use Spark to solve their problems. Then lastly, we will be learning how to learn Spark and make a career in it. So this is the agenda of the video. Without any further delay, let's get started.
So now let us understand about Spark briefly. So Spark is a cluster computing framework for real-time processing. It was Hadoop sub-project introduced in the UC Berkeley R&D lab in the year 2009, and it became open source in 2010. And in 2013, it was donated to Apache Software Foundation. So Spark provides an interface for programming multiple clusters with implicit data parallelism and fault tolerance. So now that we know what is Spark, let's actually have a look at some of its features. So Spark is real-time. That is, it provides real-time computation and low latency because of in-memory computation. And Spark is also 100 times faster for large-scale data processing. And Spark is also polyglot. That is, you can write Spark applications in multiple languages such as Java, Scala, Python, R, and SQL. Spark also has a simple programming layer which provides powerful caching and disk persistence capabilities. And Spark also has multiple deployment modes, so it can be deployed through Mesos, Hadoop via Yarn, or Spark's own cluster manager. So now, let us look at some domain scenarios of Spark. So from small startups to Fortune 500s, almost every single company is adopting Apache Spark to build, scale, and innovate their big data applications. So let us see some industries where Spark is used widely these days. So industries like healthcare, media, finance, e-commerce, and travel are extensively using Spark to add value to their business. So now let's understand how are Hadoop and Spark used together. So Hadoop alone provided limited predictive capabilities as organizations were finding it difficult to predict customer needs and emerging market requirements. But with a combination of Hadoop and Spark, companies can now process billions of events every day at an analytical speed of 40 milliseconds per event. Companies can also enhance their storage and processing capabilities by working together with Hadoop and Spark to reduce costs by almost 40%. And by deploying a big data platform in the cloud, organizations can avoid duplication by unifying clusters into one, which basically supports both Hadoop and Spark. So now many organizations are already using Hadoop and Spark together. Yahoo, Amazon, NASA, and eBay run Apache Spark inside their Hadoop clusters. Hortonworks and Cloudera Hadoop distributions come bundled with Apache Spark. Altiscale uses Spark on Hadoop to provide big data as a cloud service. And Uber also uses Spark and Hadoop together to optimize customer experience. So now let us have a look at some of Spark's APIs. So Apache Spark codes can be written in Scala, Java, Python, and R. And we can also write SQL queries with Spark. But the most preferred language along with Spark is Scala. So let's have a look at some of the features of Scala. So Scala provides scalability on Java Virtual Machine, and its performance is also really high when compared to others. Scala also provides excellent built-in concurrency support and libraries. And well, a single line of code in Scala can replace 20 to 25 lines of Java code. And Spark is also extremely fast and efficient. So now it's time to have a look at Spark's architecture. So Apache Spark has a well-defined layered architecture where all the Spark components and layers are loosely coupled. So Spark basically uses a master worker architecture, and in the master node you have the driver program which drives your application. Now you might be wondering, what is a driver program? So basically the code that you're writing behaves as a driver program, or if you're using the interactive shell, the shell will act as the driver program. Now the driver program runs the main function of the application, and it is the very place where the Spark context is created. So assume that the Spark context is a gateway to all the Spark functionalities. So Spark driver and Spark context take care of the job execution within the cluster. Now Spark context also works along with the cluster manager to manage various jobs, and cluster manager is responsible for acquiring resources on the Spark cluster and allocating them to a Spark job. Now this job is split into multiple tasks which are distributed over the worker node. So these worker nodes are the slave nodes whose job is to basically execute the task and return the result to the Spark context. Then we have the executor, which is a distributed agent responsible for the execution of tasks. So every Spark application has its own executor process, and these executors usually run for the entire lifetime of a Spark application. So in a nutshell, the Spark context takes the job, breaks the job in tasks, and distributes them to the worker nodes. These tasks work on the partition RDD, perform operations, collect the results, and return to the main Spark context. Now, if you actually increase the number of worker nodes, then you can divide the jobs into more partitions and execute them parallelly over multiple systems, and it'll be a lot faster. And with the increase in the number of workers, memory size will also increase and you can cache the jobs to execute it faster. So now let us see the various ways by which Spark can be deployed. The system currently supports these cluster managers. So we have Spark standalone cluster, which is a simple cluster manager included with Spark that makes it easy to set up a cluster. Then we have Apache Mesos, which is a general cluster manager that can also run Hadoop MapReduce and service applications. After that, we have Hadoop via Yarn, and we can also deploy it with Kubernetes, which is an open source system for automating deployment, scaling, and management of containerized applications. And Spark currently supports these three shells. We have Spark Shell with Scala support, PySpark with Python support, and Spark R with R support. Now it's time to understand about RDDs in Spark. So when it comes to processing the data over multiple jobs, we need to reuse and share the data, which can be achieved through in-memory data sharing, which is actually a lot faster than network and disk sharing. And RDDs help in achieving this in-memory data sharing. So RDD stands for Resilient Distributed Data Set, and it is the fundamental data structure of Apache Spark. So by resilient, I mean fault tolerant, as it can recompute missing or damaged partitions in case of a node failure with the help of RDD lineage graph. And it is distributed since data resides on multiple nodes. And dataset basically represents records of the data you work with. So the user can load the dataset externally, which can either be JSON file, CSV file, text file, or a database. So now let's actually implement a demo on RDDs. So we'll start off by understanding how can we create RDDs. So there are three ways to create an RDD in Spark. So the first way would be to parallelize already existing collection in a driver program. The second way would be to refer a dataset in an external storage system. And the third way would be to create an RDD from already existing RDDs. So let's create an RDD by parallelizing a collection. So this would be the syntax for that. So first we'll create a collection, and this collection is a list which contains these three elements: Spark, Scala, and Hadoop. And then we'll use sc.parallelize to parallelize this collection, and we'll store this result in my first RDD. So this is one of the ways by which we can create a Spark RDD. The second way was to reference a data set in an external storage system. So let's do that. So I'll just type in val and then give a name to the object, which would be, let's say, text RDD, and then let me load this external data file. So the command would be sc.text file, and then I will give in the path, right? So this was the second way to create our RDD. And the third way to create RDD is to transform an existing RDD. So we'll do that using the filter function, right? So over here, we already have an RDD which is text RDD, and on top of that RDD, I am using this filter function, and I will be extracting only those elements where it contains the string Spark, and I will assign to this result new RDD. So these are the three ways by which we can create RDDs in Spark. So now that we know how to create RDDs in Spark, let's go ahead and perform some operations. So the first set of operations would be the transformation tasks. So the Spark transformations basically produce new RDDs from the existing RDDs. So it takes RDD as input and processes one or more RDD as an output. And each time it creates a new RDD whenever we apply any new transformation. So the first set of transformation function would be the map function. So this map function iterates over every line in RDD and it splits it into a new RDD. So using the map transformation, we can take in any function, and that function is applied to every single element of RDD. So what I'll do is I will go ahead and create an RDD with the name X, and this RDD is made by parallelizing this collection. Now what I want is, using the map function, I want to add the number 1 to each of these existing element. So this would be the command for that. So on top of this RDD X, I'll apply the map function, and this will take in every single element and add 1 to that element. I'll hit enter. Now let me just type in y dot collect, and let's see what is the final result. So over here we see that these were the initial values, and after applying the map function on top of this, 1 has been added to each of the individual element. So initially it was just Spark. After using the map function, it became Spark1. Initially it was just RDD. After using the map function, it became RDD1. So this is how we can use the map function. So now we'll go ahead and work with the flat map function. So with the help of flat map function, to each input element, we can have many elements in an output RDD. So the key difference between map and flat map is that map returns only one element, while flat map can return a list of elements. So over here, what I'm doing is, I have a list 1, 2 and 3. And what I want to do is, I want to duplicate each of the individual element 3 times from this RDD. So I'll use the flat map function, and I'll take this element and I want to duplicate each of the element 3 times. I'll hit enter and let's see what do we get. So this was our initial RDD, and after applying the flat map operation, we see that each element has been printed 3 times. Now let's say instead of 3 times, I only wanted to duplicate it 2 times. So what I'll do is I'll remove this X, I'll remove comma over here. Now I'll hit enter. So see that we have duplicated this initial RDD like this. So the duplication is twice over here. So after this we have the filter function. So the Spark RDD filter function returns a new RDD containing only the elements that meet a predicate. So it basically narrows operations because it does not shuffle data from one partition to many partitions. So I'll go ahead and create an RDD which contains the first 10 numbers. Now from this RDD, I would only want the even numbers. So to do that, I can use the filter function. So on top of this numbers RDD, I'll apply the filter function, and I will extract only those elements where the remainder is equal to 0, and then I'll collect the result. So this was our initial RDD, and after applying the filter function, we have extracted only the even elements. So the next function is intersection. So when we apply the intersection function on two RDDs, we will get only the common elements between the two RDDs. And the key rule of this function is that the two RDDs should be of the same type. So I will go ahead and create two RDDs. Right, so first I am creating an RDD with the elements 1 to 9. After that, I am creating another RDD with the elements 5 to 15. Now, what I'll do is I will apply the intersection function between these two RDDs and let's see what do we get. So we see that we have only the common elements from these two RDDs. So the common elements are 5, 6, 7, 8, 9. So these were some of the transformation functions. Now after that we also have something known as actions. So while transformations create RDDs from each other, but when we want to work with the actual data set, at that point action is required. So when the action is triggered after the result, new RDD is not formed like transformation. Thus, actions are Spark RDD operations that give non-RDD values. So the values of action are stored to drivers or to the external storage system. So this basically brings in laziness of RDD into motion. So now let's work with the first action task, which would be reduce. So the reduce function takes the two elements as input from the RDD and then produces the output of the same type as that of the input elements. So let's say I create an RDD for the elements 1 to 10. Now what I want is the sum of the first 10 elements. So I'll use the reduce function, and what I'll do is I will add each element with the next element, and this should give me the sum of all the elements in this RDD. So when you add up all the elements from 1 to 10, the final result would be 55. Similarly, let's say I create an RDD which would have these string elements Abe, Abby and Apple. Now what I want is in the final result, I would want a concatenation of these three strings as the final RDD. So let's again implement the reduce function on top of this RDD. So here what I'm doing is I am taking each string and concatenating it with each other. So this was our initial RDD which contained three individual strings. We have applied the reduce operation on this and we have got a final string which is a concatenation of these three individual strings. So after this we have the first function. So the first function, as the name states, basically gives us the first element of the RDD. So I'll create an RDD like this which contains these three elements Apple, BT and Beatrice. So I'll apply the first function on top of this names to RDD to get the first element, right? So see that the first element is Apple and that is what we have extracted. And then we have the take function which returns the first n number of elements from the RDD. So over here I create an RDD nums which contains these elements. Now let's say if I wanted only the first four elements. So I'll just type in nums dot take and then the parameter would be 4 since I want the first four elements. So here I see that I have extracted only the first four elements from this entire RDD. And then we have for each partition, which basically executes a single function for each partition of the data frame. So let's say I create a Spark RDD with these elements 1 to 9 and each partition would have 3 elements. So 1, 2, 3 would come under first partition, 4, 5, 6 would come under second partition and 7, 8, 9 would come under the third partition. Now what I want is for each of these three individual partitions, I want the sum of the elements, that is 1 plus 2 plus 3 for the first partition, 4 plus 5 plus 6 for the second partition and 7 plus 8 plus 9 for the third partition. And this would be the syntax to do that. So on top of this RDDB, I am applying the for each partition function and I will be printing the sum of all the elements for each individual partition. So I'll hit enter. So we see that when we add 1 plus 2 plus 3 we get 6. When we add 4 plus 5 plus 6 we get 15 and when we add 7 plus 8 plus 9 we get 24. Right, so that was a demo on Spark RDDs. Now let us understand the various components of Spark ecosystem. So let me start with the Spark core component, which is the most vital component of Spark ecosystem. So it is responsible for basic IO functions, scheduling, monitoring and so on. And the entire Spark ecosystem is built on top of it. So now you know how important it is. So as we already saw, Spark supports different deployment modes. It can be deployed through Hadoop via Yarn, Mesos or Spark's own cluster manager. Now let's have a look at Spark's ecosystem library. So the library is composed of Spark SQL, mllib, GraphX, and streaming. So Spark SQL helps us in performing SQL-like queries to process the data. Then we have Spark's machine learning library, which eases the deployment and development of scalable machine learning pipelines like summary statistics, correlation, and feature extraction. And graphics component of Spark helps the data scientists to work with graphs and non-graph sources to achieve flexibility and resilience in graph construction and transformation. Then we have the Spark streaming component, which allows us to perform batch processing and streaming of the data in the applications. And since Spark is polyglot, it can be implemented in Scala, R, Python, and Java. However, Scala is the widely used language. And when it comes to storage, we can store data over HDFS, local file system, and cloud. It also supports SQL and NoSQL databases. So now, let us deep dive into the Spark components. So we'll start with Spark SQL. So Spark SQL is a Spark module for structured data processing. And the code for Spark SQL can be written in Java, Scala, Python, or R. And Spark SQL helps to query data from data sources like CSV, JSON, Hive, and Cassandra. And we can also seamlessly mix SQL-like queries with Spark programs. So Spark SQL lets us query structured data as a distributed dataset or RDD in Spark with integrated APIs in Python, Scala, and Java. Another good thing about Spark SQL is it provides unified data access, so we can load and query data from a variety of sources. Schema RDDs provide a single interface for efficiently working with structured data, including Apache Hive tables, Parquet files, and JSON files. Spark SQL also has Hive compatibility, so we can run unmodified Hive queries on existing warehouses. Spark SQL reuses the Hive front end and metastore, giving us full compatibility with existing Hive data queries and UDFs. So we simply have to install it alongside Hive. Another notable point is it provides standard connectivity through JDBC or ODBC. So Spark SQL includes a server mode with industry standard JDBC and ODBC connectivity. And finally, Spark is also scalable. So Spark SQL takes advantage of the RDD model to support mid-query fault tolerance, letting it scale to large jobs too. Now let's have a look at some advantages of Spark SQL. So the execution of queries in Spark SQL is much faster than Hive. So let's say if it takes 600 seconds to execute a query in Hive, it will only take 50 seconds in Spark SQL. And there are no hurdles if you want to migrate the Hive code to Spark SQL. And as we already know, we can do real-time querying with Spark SQL. Now let's look at the Spark SQL architecture. So let's start with a data source API. So this is a universal API for loading and storing structured data. And it has built-in support for Hive, Avro, JSON, JDBC, and Parquet. It supports third-party integration through Spark packages and also has support for smart sources. Then we have the DataFrame API, which is a distributed collection of data in the form of named columns and rows. It is basically equivalent to a relational table in SQL used for storing data in tables. And it is lazily evaluated like Apache Spark transformations and can be accessed through SQL context and Hive context. And the next component is SQL Interpreter and Optimizer. So SQL Interpreter and Optimizer is based on functional programming construct in Scala. It is the newest and most technically evolved component of Spark SQL and provides a general framework for transforming trees, which is used to perform analysis, optimization, planning, and runtime code spawning. It also supports cost-based optimization and rule-based optimization, making queries run much faster than their RDD counterparts. And there is also SQL Service, which is the entry point for working along structured data in Spark. It allows the creation of DataFrame objects as well as the execution of SQL queries. So now, let's learn how to create data frames and work with Spark SQL in Spark. So we'll start off by learning how to create a data frame in Spark. So I'll create a list with these three elements. So the first element has 1 mobile and 50,000. The second element has 2 shoes and 4,500. And the third element is 3 TV and 70,000. Now what I want is to convert this into a data frame where this will be the first row, this will be the second row, and this will be the third row. And to do that, I would have to use the toDef function. So on top of this object which I've just made, product, I will use the toDef function and I will give the names of the three columns. So the name of the first column would be PID, the name of the second column would be product, and the name of the third column would be value. So now let me have a glance at the data frame which I've just created. I will just type out product df dot show. So we have successfully converted this list into a data frame where this became a first row, this became a second row, and this became a third row. Now we'll go ahead and do some basic operations on Spark data frames. So here I am reading a JSON file as a data frame. So the command for that would be spark.read.json, and inside this I will give in the path which is student1.json, and I will store it in df. So df is a data frame. Now as we had already seen earlier, if you wanted to show the elements or the records inside the data frame, we will use the df.show function. And if we also wanted to see the schema of this data frame, then we'll use the print schema function on this data frame. So df.print schema tells us that this data frame has two columns. First column is age, which is of type long. Second column is name, which is of type string. So now what I'm doing is, with the help of the select function, I am extracting only the name column from the entire data frame. So df.select name. So this data frame actually has two columns, name and age. But if I want to extract only individual columns, then I'll use the select function. So df.select name, and then I'll show it out. So we have extracted only the name column. Now similarly, let's say I wanted to extract only those records where the age of the person is greater than or equal to 18. So for this, the command would be this. So on top of the data frame, I'll use the filter function and specify the condition that age needs to be equal to or greater than 18. So we have 3 records, but out of those 3 records, we get only these two, because Janet's age is equal to 18 and Serena's age is more than 18. And then in the final command, we are grouping the data frame with respect to the age column, and I want to find the count of number of persons for each age value. So there is one person with age 18, one person with age 17, and one person with age 19. So these were some basic operations on Spark data frames. Now we will go ahead and apply some Spark SQL queries on top of the same data frame. So for that, I would actually have to create a temporary view. Command would be create or replace temp view, and then I will pass in the name of the data frame, which would be student1. So let's go ahead and apply our Spark SQL queries. So in the first command, what I'm doing is I am extracting all the records. So we have a simple SQL query, select star from student1, which gives us all the records from this table. Now similarly, if we wanted only those records where the age is equal to 17, this would be a syntax. So select star from student1 where age equals 17, and this is the result which we get. So now let's understand about Spark's machine learning library, mllib. So mllib basically consists of two packages. First is spark.mllib, which contains the original API built on top of RDDs, and it is currently in maintenance mode. The second package is Spark-ML, which provides higher level API built on top of data frames for constructing ML pipelines. And Spark.ml is the primary machine learning API for Spark now. So with the help of mllib, you can implement statistical analysis, you can implement classification and regression algorithms such as linear regression, naive Bayes, and decision tree. mllib also supports clustering algorithms such as k-means and Gaussian mixture. So there are multiple things which you can do with mllib. Now let us implement a demo on mllib. So let me start off by loading all the requisite packages first. So we will basically be implementing the linear regression algorithm. Now let me load the dataset and show you guys the schema of this dataset. So over here we are loading a CSV file with the name e-commerce customers, and we are storing it into a data frame, and the name of that data frame is ecom.ds. Now after that we have printed the schema. So you see that these are the different columns available in this data frame. So we have email, which is of string type, address, which is of string type again, avatar, which is of string type again, and then we have these double values: average session length, time on app, time on website, length of membership, and yearly amount spent. So we basically want to apply the linear regression algorithm on top of this yearly amount spent column. So this yearly amount spent column would be the dependent variable, and the rest of the double values would be the independent variables. So average session length, time on app, time on website, and length of membership would be the independent variables, and yearly amount spent would be the dependent variable. So now what I'll do is I will go ahead and select only these double values from this entire data frame. So I'll use the select function, and I will be selecting this yearly amount spent column as label. So I will name this column as label, and the other columns I'll be selecting the same, and I'll store this result in ecom.df1. After that I'll use a vector assembler, which helps me to take in all of these independent variables and store them in a single column and name that column to be features, right? So this is the syntax. So I'll type new vector assembler, and I will first take in all of the input columns, which are nothing but all of the independent variables. So these are all of the independent variables, and I will be storing them under one new column and name that column to be equal to features. And I'll store this in an object and name that object to be assembler. So after this I'll apply this transform function on top of the ecom.df1 data frame. So over here we are basically creating a data frame which will have just two columns. First is the label column, next is the features column. So this label column would be our dependent variable, and this features column has all of the independent variables, and we are storing that in ecom.df2. So now let me just show you guys how the data frame looks like. So I'll type in ecom.df2 dot show. So this is our final data frame. This is our dependent variable with the name label, and this is our independent variable features, which contains all of the independent variables. So after this I will go ahead and create a new linear regression object and name that to be LR. So we can create a new linear regression object with the help of this linear regression function. Now after this we will go ahead and build the linear regression model on top of the ecom.df2 data frame. So the function would be lr.fit, and I am storing the result in LR model. So now that we've built the model, let's actually have a look at the training summary. So over here I will use the summary function on top of the model which we've just built, and I'll store it in training summary. And I would want to know the residuals of this training summary. So these residual values are basically the error in prediction, or in other words, the difference between the actual values and the predicted values. So over here these are all of the residuals for the first 20 rows. Now let's also have a glance at some performance metrics. So we are printing the root mean square error, the mean square error, and the R square value. So we see that the root mean square error value is 9.92, the mean square error value is 98, and the R square value is 0.98.
Just a quick info guys, test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and data frame? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now let's continue with the session.
So let's see how to deal with different types of data. And now what I want to show you is how to deal with something called JSON data. So basically JSON is not binary file. JSON is one of the most widely used file formats, especially in the case of big data. Well, you see JSON everywhere. Yes. So JSON stands for JavaScript Object Notation. JavaScript Object Notation. That is called JSON. To put it very simply, it is the format in which you will represent your data as a key value pair. Right. So, and why JSON is important? Because there are many platforms who are going to give you the data in the form of JSON. We had many customers, for example. So there are customers who are dealing with this so-called IoT, Internet of Things related data. So if you have a customer who is actually dealing with IoT kind of data, then what happens is that the data that the sensors are collecting normally comes in the JSON format. Not only that, there are many applications which will give you the data in the JSON format, because JSON is a widely accepted, popular, and standardized way of representing your data. So chances are very high that you will see the data coming in JSON format. And it is called a JSON object. So if you are a person who is coming from the object-oriented programming side, it's very easy for you to programmatically access the data. That is the advantage. So if I'm getting a text file, okay, the text file is not an object, right? So, but JSON is an object actually. So if you can actually call it in your program and natively work with this type of data. And this is primarily the reason why NoSQL databases like MongoDB are extremely popular. Now, if you go to the NoSQL side, you have a database called MongoDB. I'm quite sure that most of you could have heard about it. The reason why MongoDB is number one in the market is because it stores the data as JSON. So that internally JSON, but yeah, representation is JSON, right? Because then programmers can directly play around with the data, right? So not only in the NoSQL side, in many areas, this JSON data is very important. So now our problem is that we have some JSON data and we want to read it and analyze it inside Spark, right? So let me do one thing. Let me show you a use case or a case study rather than just showing you this. So let me figure out where is the data first, okay? I think here we have the data. I just need to upload this data, okay? So what I'm gonna do, I will just upload the data, and that may take a while and I will explain it. Meanwhile, what am I going to do? So I will just drag and drop this. So I will take a small case. So when you want to run a Spark program in production, you package it. The only difference is that you package it. And for that, you are using SBT. And we have already demonstrated how to work with SBT, right? Any program that you have, you can compile it and get a jar file, right? You submit the jar file. That is a difference. No other difference. But you can also use the shell. There are people who use the shell also. It is not like a hardcore way, say that you must always use the jar file. Like I use shell all the time, not the jar side, because sometimes you just want to, see what is happening. So when you submit a jar file, that's not possible, right? So we had discussed SBT, right? SBT is the way to productionize your program. Yelp was the original company who invented this idea of local business listing of restaurants. So basically what Yelp does is it's like Zomato. You can find restaurants to eat, you can have reviews, and then you can book a table if you want, you can have takeaways and all these things. So basically it is local business listing, especially for the restaurants, right? Restaurant side. And so I can just search for something. For example, I can say, I want to find restaurants in San Francisco, and you will get. This is what they do. I mean, that's what it does. Now, even if you open a restaurant, you will get tons of information about the restaurant. Like you have the name, the star rating, the address, the phone number, the pictures, the reviews, reservation details, so many other things actually. So Yelp has a huge amount of data related to all the restaurants, right? Now, Yelp also allows you to sort of like download the data, right? So all this data that they have is public data. So you can actually visit their website and you can download all the data that they have. There's a file called a business.json, and that is the file. Now, the idea is when you download the data, it comes in the JSON format. And this is how the data looks like. So this is the original Yelp data. So basically, this contains all the restaurants, probably not all of them, but some of the restaurants which are listed in Yelp, right? And let's say our requirement is that we want to load this data into Spark, and then we want to ask some interesting questions about the restaurants, right? So we are interested in, loading this data into Spark and then answering some interesting questions. Let's say how to do that. Now, if you want to have a look at the data, you can see that every restaurant will have something called a business ID. That is a unique business ID. And then you will have this full address of the restaurant. And then you have this hours key. Within hours, so how hours is a key, then Tuesday is the value. Again, it is nested. Tuesday becomes the key, close becomes the value, and then you have all the days and all. Then you have categories, then you have a city, and then latitude, longitude, so many other things. So if I scroll down, some of the restaurants will have much more interesting information. For example, I don't know. There is something called business info. Let me just try to get it, okay? City review count, attributes. Look at this. So this attributes is something very interesting. For example, these are two restaurants and I'm just showing you the attributes. In the first restaurant, the attribute says it allows no parking, no street parking, no valet parking, I guess. Accept credit cards, true. Wi-Fi, no. Price range. So this is the attribute of one restaurant. But if you look at the attribute of the second restaurant, see there is more, right? These are all the attribute. For example, what kind of a music do they provide? What kind of an ambience do they have? And classy, trendy, upscale. Do they support smoking? Accept credit card, takeout, happy hour, outdoor seating, Wi-Fi, diner. So many things are there. So the point that I'm trying to tell you is the data is not really properly structured. If you try to put this in a table, one restaurant may have 20 columns, the next restaurant may have 100 columns. Because that is how the business is. When you are listing your restaurant in Yelp, Yelp cannot say that your restaurant must have 10 features or something, right? So every restaurant will have its own different features and options and all. So this data is not really something which we can easily analyze and put it in a row column structure. But anyway, let's see how to play with it in the Spark SQL side. So I also need another file. Yeah, so what I'm going to do, so the first question will be naturally, how are you going to read it, right? So let me start the Spark shell first. So this is semi-structured data. So JSON files are actually semi-structured. They fall in the category of semi-structured data. Now, in the traditional world, let's say you are not using Hadoop or Spark or something, like you are in the traditional world. So normally what people do, there are JSON parsers. You can use something called a parser library and you can read it. But the problem is that will work if your data set is kind of like small, right? So now what I want to do, I want to read the data. So what I'm going to do, I will simply say spark.read.json, business.json. So the data is in Linux, not in Hadoop, right? Let me just upload it. So how do you copy that? DFS hyphen put the file to user.
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Training. Okay. And now let's run this. So, by the way, this file has a lot of columns and a lot of data, but look at what I have done. I simply did a spark.read.json and gave the file. All I did is I used this method spark read JSON and then said that, you know what, this is the file you want to read it. And Spark automatically read the file, sampled it, figured out the schema, and created a data frame for me. So the data frame is already created. Its name is BIS. Now, if I show you the data frame, you may not be able to understand because there are too many columns actually. So I mean, like it doesn't fit on the screen really, but the data frame is there. Now, what is more interesting is that if you look at the schema of this guy, look at the schema. All the column names and their data types, everything is automatically inferred. Don't you think this is really interesting? Because you don't have to spend any number of time understanding what is the structure, where it is, how many columns are there. All you need to do is that simply say spark.read.json, right? And there are nested columns, so that is very interesting, right? So the top column right now, it says there is a column called attributes. Within that, there is a column called alcohol. So if you want to get this alcohol column, you can say attributes dot alcohol because it is a struct data type, right? And all the columns are red, so that is the beauty of it. Now, what I want to do, so this is my data frame. So I will say create or replace temp view, and I will just call it as base. So what I'm going to do, I'm going to register this JSON file as a temporary view, right? So that we can run SQL queries, right? And once I have it, I can simply start running SQL queries. For example, let's say we want to know how many restaurants are there. So I can simply do a select count one as business from biz. So there are a total of 61,184 restaurants, right? You want to get the group state-wise number of restaurants. So what I'm going to do, I'm saying that, select state comma count one as business, group by state, then show 10. And see, it is faster, right? It is not like Hive. You have to understand that you are looking at 61,000 lines of data, that too nested JSON. And if you run a query, the answer is getting in less than a second or two. That means it is fairly fast. It's not like Hive, right? Well, so what is this query? You are basically getting the state-wise number of restaurants, and I'm just doing a show 10 to get the top 10 restaurants. And let's also do a order by query. I'm again selecting the state, count one as business. I want to group by state, order by business in the descending order. Okay, and we want a show 10, let's say. See, very, very fast, right? So you're basically ordering the data based on the number of restaurants of each state. Like Arizona has around 25,000, Nevada has 16,000, etc., etc. Right? So you can run any SQL query that you want. And I just wrote some queries. I will share this with you. For example, you can actually write any type of query. So this one here says, I want to select the name, stars, review count, where the city is Las Vegas, order by stars in descending, review count descending, limit 5. Or let's do a show 10. Do we have a show 10? Yeah, only 5 are there, right? Total. Yeah. So the basic idea is to demonstrate that it is very easy to work with JSON data, especially when you're having Spark SQL, right? Google download Yelp data, you will get first link. Okay. Is data frame biz changed? No. What is a data frame behind the scene? A data frame is nothing but an RDD. So the original data frame never changes actually when you run a query, right? Anyway, you got the idea, right? It's very easy to play around even with nested JSON data if you have, and all you need to do is spark.read.json, and then you can work with JSON data. Can I save the table in Spark? Yes, you can. Okay, I will show you that in another example. Dealing with XML data. Okay, so let me see if I have the file available. So I just need to upload it only, hdfs -put. I will just upload the data, okay? Then I'll show you what I'm talking about. Training. So now the question is that what if I have an XML file to play around with, right? Well, you are not running Hive queries as such, you are running SQL queries, but you can integrate with Hive to read from Hive, right? But let's say you want to, read XML data. Well, couple of things you need to understand is that even though Spark SQL supports reading XML files, it may not work in every possible scenario. So I should also give you the real picture, right? In the sense like XML is probably more common than JSON, right? So there are many cases where you get XML files as the output, right? You go to all the ERPs, right? For example, I mean, simple examples I'm giving. Let's say you are using something like Tally. Tally is an ERP, right? So Tally has this TDL file, and if you read it, it will by default give you as an XML if you want to process it further, right? So XML files are very common, and Spark SQL has a way of reading XML files. Now you can try that. Let's say in your project, your requirement is that you have a bunch of XML files and you want to read it. Yes, please, you can try that. But in case if it doesn't work, the XML reader doesn't work, then you need to write your custom parser for reading. And we have done that in many cases, right? We had a client 24/7. So 24/7 is a BPO or a call center company. So basically they provide this customer services like call center, chat support, etc. to clients in one of their project. So what they do, they have this call data. So let's say you're calling customer care, right? What happens? When you call, you will be redirected to this IVR, and the IVR will say that press 1 for English, 2 for this, 3 for that. So you do that, right? So that is recorded in something called a VXML or a voice XML. So basically that XML file will contain the metadata, the duration of the call, what the customer pressed, 1, 2, 3, and how long he took to press, etc. So this data, so they had like millions of records in this data because they had a lot of call center business. So every day what will happen, we will get this data, this VXML, right? And we were not able to convert it using Spark. So that's what I'm saying. In all the cases, the XML conversion will not work. And they wrote their own parser to convert the data. But just to show you an example of how to do this. So this is the XML file that I'm going to use. And this is a very simple XML file. It's not like very complicated or something. So an XML file normally has a root tag and a row tag. So this employees is called the root tag. That is like the outer tag. And then you have this employee, that is the inner, or we call it as the row tag. So when you want to read an XML file, you need to identify what is the root tag and what is the row tag. Once you identify that, well, directly Spark doesn't have any capability to read an XML file directly. So what you need to do, I will exit the shell and again search for Spark XML Databricks. So there is an XML data source for Apache Spark, and you can use it for reading the XML. So what you need to do, you need to say you want to start the Spark shell. Okay, so normally you will simply say Spark shell and that will start it. But now what you need to do, you have to say, I want to start the Spark shell hyphen packages, and you then give the name or the Maven coordinates of this Databricks Spark XML package. So if you are wondering from where I got this, it is from this website. So if you go here, it will be written how to start. See? So you have to simply say Spark shell and this command, right? This is the same command I'm typing here, right? So you just say Spark shell packages and then you just give this. And what will happen if you run this? It will download this XML dependency to your session. It is basically going to add this XML package or the XML parser to your Spark session. And then you will be able to read it. So I started the Spark shell. So what am I trying to do here? I'm saying spark.read.format. Okay, and then I'm gonna give the name of the reader, that is nothing but com databricks spark xml. What are the options? Infer schema true, because I don't want to mention the schema. Please find it automatically. What is the root tag? Employees. What is the row tag? Employee, and then load the data. So this will automatically read and convert your XML file into a data frame structure. But so if I look at the data frame, right, that we just got, what is its name? Employees df.show. The data frame looks nice, but the problem is that if you look at the first column, the address column is actually struct, I think. If I look at the schema, the address column is of a data type called a struct, which means within the address column, you have 3 more columns: city, country, pin code. That is how it will read. So if you want to run SQL queries and all, one thing you can do is that you can say address.city, address.country, like that you can say, right? But an easier way will be that, you can again expand it. So I can simply say where, I just want to select employee number, employee name, address dot city, address dot country, etc. So you see the new data frame, this has the expanded columns, meaning it's easy for you to work on the data, right? And now you can do what? You can register it as a view, start running your SQL queries. The same story follows after this, right? So the point is how to use this XML package. So what you need to do, start your Spark shell with the package option. And once you have it, read the data like this. You just need to give the name of the reader, what is your root tag, what is your row tag, and the file name. And then you will be able to work with it, right? How do you actually copy files from Linux to Hadoop in production environment? Well, if the file is already in Linux, we do the same thing. So let's say you already have a file in Linux, you want to put it in Hadoop. We do the same thing, HDFS, DFS put, but that situation is very rare. So normally we have data ingestion techniques. So if you have heard about Scoop, Flume, Kafka, Kinesis, So there are data ingestion tools which can ingest your data. Package option is same. Package argument is same, right? So right now I'm using this XML argument. Now there is a file format called Avro. Okay. So right now you may not have it, but I'm just saying, let me just show you.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD, B. DataFrame, C. Dataset, D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
There is a file format called Avro. Okay. Avro is a serialization format, right? It is used to serialize your data, Avro files, right? Well, the representation is different. Like JSON is key value. Avro is not key value. Avro is proper serialization, right? JSON is not serialization. JSON is what? You're just representing your data as an object. Avro will actually allow you to compress the data, save some space if you want. Well, we are not going to discuss Avro, but my point is, if you get an Avro file, imagine. So let's say you are working, you got an Avro file. The file format is in Avro. Then you will be thinking, okay, now I want to read Avro. What will I do? So there is an Avro reader. So you can search for these things, right? So in fact, you can actually search in the GitHub Spark scikit-learn, that is for machine learning, Spark CSV, and Spark Avro. Probably there is a direct method now. There is a Spark Avro. See? So if I get an Avro file, you can read it. It is archived. I don't know why. So some of the things you will learn while you're working. So not everything can be taught also, right? Also, it doesn't make any sense. So I'm taking a class where I'm showing you how to read 100 different type of files. That's useless, I believe, right? It doesn't make any sense, right? Some of the common formats, yes, it makes sense. So even though you learn all this, probably when you start working in production, you will get a file which nobody is able to understand. Even nobody could have seen that format again. You need to figure out how to read it. If Spark is not able to read it, use a parser. You write your own custom code, convert it, and then read it, right? So those are some of the challenges we face actually. For XML, the option is same, but for other formats, so this is how you deal with XML data. We can use third-party library to load and implicitly infer XML schema in a data frame. We saw that already, right? And dealing with Parquet files, right? Parquet is a compression format. So it is nothing but compression. So when you're talking about compression techniques in big data, there are three major formats that we have. There is something called RC, then there is something called ORC, then we have something called Parquet. These are the three formats that we have for compression. What is the difference? Well, beyond the scope of our discussion, but I will tell you, ORC is the best compression format so far. ORC stands for Optimized Row Columnar Format. So far, the best compression format is ORC. No questions asked. Then the next one will be Parquet. Then the next one will be RC. In fact, RC is sort of like very old. So this is very old. I don't think much people are using it. This one. Mostly people prefer ORC or Parquet. Now again, there is this competition. If you are using Hortonworks, you will see ORC more. If you are using Cloudera, you will see Parquet more. So Hortonworks was originally, I think they were contributing a lot to the ORC project. So when you start working on a Hortonworks platform, right? Hortonworks will say that, you know what, if you want to compress your data, please use ORC format. And even Hive and all supports ORC extremely well. And ORC is the best, no questions asked. ORC can even do things like indexing internally. So it's one of the best formats ever created, no questions asked. But when you go to the Cloudera platform, Cloudera will say that, well, not use ORC, use Parquet. Well, you don't have to understand much about how this is happening, The only thing is Parquet files are compressed files, right? Heavily compressed, right? So I think Parquet will achieve around 50% compression. Like if I have a 100 GB file, it will compress to around 50 GB. And this is really, really important because you never want to store the data as it is on big data clusters, because that will consume a lot of space for you, right? So people are always searching for ways to reduce the total file size, right? And Parquet is what you have in your syllabus because you are learning Cloudera course, right? You are learning CCA 175. So, but yeah, ORC is very nice. I personally prefer ORC over Parquet in any situation. But Cloudera's official documentation says use Parquet. Cloudera likes Parquet. So we are going to learn Parquet for sure, right? So the point is that if you have a Parquet file, how do you read it, right? I think Spark has an ORC reader now. So if I say spark.read dot, you can read ORC or you can read Parquet. There is no RC reader, I guess. RC is no longer there. But let me show you a sample so that you understand how this Parquet files looks like. So people will be thinking like, what do you mean by a Parquet file? Do we have the file? There is a file called babynames.parquet. Can I upload it? Babynames.parquet to user training. Oh, it's already there. Babynames.parquet. So the point is, this is the file babynames.parquet. Okay, and you cannot read it normally. So if I try to read it, you cannot, because Parquet is a specific format, right? Using your normal text editor or anything, if you try to read it, you will never be able to read it as such, right? So that is why you can use the Parquet reader. So I can simply say val babydf equal to spark dot read dot Parquet babynames dot Parquet. Very easy. And if I do a baby names, well, this is how the data looks like. You have an year, the name of the baby, the probability, and the sex, boy or girl. Some sample data I have, but you got the idea anyway, right? So you will be using this reader for Parquet. That's my whole point, right? So I told you that Spark SQL has excellent connectivity options, to read the data from things like RDBMS, right? So how can you read the data from RDBMS? Let's have a look at it. Okay, so I will show you that. And then Hive is also there. We will look at Hive as well, don't worry, right? Okay, so we have it. I just need to search for a file, then I will tell you what we're talking about. MySQL-connector.java. MySQL-connector.java. Okay, inside this .bin.jar file. Okay, so we got it. Right, so let's do one thing. Let us first verify whether MySQL is running on our cloud lab. So in the cloud lab, we already have the MySQL, and let me try to log into that. So I'm just going to type this command. Okay, so we have logged in. So we already have MySQL running, and let us see whether MySQL has some data. Show databases. Oh, very well. We have a lot of data actually. So there is a retail DB, and I can say use retail DB. Show tables, customers, orders. Select star from orders. Well, you got the idea. So I have a MySQL database, which is running on the Cloud Lab, right? And it has a database called a Retail DB. Within that, there are some tables. So I just did a select star on one of the table called orders table. You can see there are around 68,000 rows, and there is an order ID, order date, the amount, and the order status, kind of like a schema. Now, what is our requirement? I want to read this table into Spark directly. Well, I want to read it. How can I do that? Now, if you want to do this, the first thing you need to understand is that you need the MySQL connector or MySQL driver. You understand that, right? Whenever you want to talk to any RDBMS, be it Oracle or MySQL, you need the JDBC or DBC driver. Then only you can talk. Point number one. So I'm going to verify whether I already have downloaded it or not. Let's quit from here. CP MySQL. There is a MySQL connector.jar. I am assuming this guy should work. Okay, so 5118.jar. Where can you get it? You can go to Google, right? So you can just go to Google and do what? Download MySQL connector jar. And the first link that you get is the MySQL download page. That is from where you can download. I think you guys understand it. So I already have a MySQL connector Java 5118.jar. So this is already there. And let's see if we can use this. Now, how do you use it? First, exit from the Spark shell that you have. And you need to start the Spark shell with a couple of arguments. Let me show you what it is. So we will say Spark shell. Let me just copy paste it, okay? MySQL connector Java. What is the version we are using? 5118. 5118.jar. Yeah. So what I'm going to do, I'm going to start my Spark shell with this argument. I'm going to say that start the Spark shell, the driver class path, and the connector jar file is this. So basically it will add the driver to the session. That is basically what is going to happen. Let's try that. Okay, started. But now the question is that how do I read the data, right? To do that, what you need to do is, see, you have to create something called, Java utilities properties object. So there is a Java util properties class. All you need to do is you instantiate this class and then you create an object. That object is called prop. It can be any name. Why are you creating this object? Because this object has some local host. Database is retail DB. Table name is orders, and then it should work. So let's try this first. The driver class is also correct as per me, because I had been running this for quite some time. So JDBC, now it is trying, it read. So it read, I mean, there is a warning, but it read. What was the error? I did not add this slash. So in the connection string, right? So how do you read it? So like I said, you have to put the username, password, the driver class, and the URI. And I read it as empdf. So if I do a empdf.show, that's it. This is your data from MySQL, right? But tell me one thing. Why do you want to do this? What is the practical scenario? Why do you want to read the data from, say, MySQL into something like Spark? Why? Why do you want to do this? So no, it's not for speed, right? See, MySQL in its own class is very fast, right? So you are using MySQL as an OLTP system, RDBMS, right? And it's really fast, faster than Spark for sure, right? So you are not reading this so that Spark will become faster or Spark will become better. That is not the idea. And also we do this if you want to do things like join operation, like you have a very large data set, like a data frame, and you have a small data that is already lying in MySQL. You want to do a join operation, this is what you do. Because that is the only situation, otherwise you don't really read a lot from RDBMS and then process the data, right? So one thing that people have been asking is that how do you actually connect with Hive? Okay, so the question is like, I have Hive, and how do you access Hive? So let me do one thing. Let me start Hive and check whether we have something. So Hive is here. And if I do a show databases, okay, there are some databases. And let's see if I can use some of them. Use movie analysis, show tables, no tables, Intellipaat. Let's look at this. The only thing is that, okay, so there is this retail DB, I think probably we can use it. This should have a select star from departments. Okay, so some data is there, I think, in departments. So the database name is what? Retail DB departments. So there has been a lot of confusion around integrating Spark SQL and Hive. So as per the slides, when you say you want to integrate Spark SQL with Hive, right? Well, one way to do this is that you install Spark and Hive everything in your setup. So let's say you are using a new setup, right? So you install Spark, you install Hive, right? And Hive has a configuration file called Hive site XML, right? So there is a file called Hive site XML, and let us look into that. Hive installed Hive/conf. So can you see there is the file called a hive-site.xml file. So typically what people do is that if you are working in a big data infrastructure, this will be done by the administrator. What he will do, he will copy this Hive site XML file to the Spark folder. So if I go to Spark-Conf, it should be here. So here is the Hive site XML. So first thing you need to do is that you have to make sure that you copy the so-called Hive site XML file from the Hive configuration folder into the Spark configuration folder. And you don't have to really worry about this because see, when you are working in a company, this will be already done and set up by your administrator, Hadoop administrator or Spark administrator. Now let me see what we are going to do. So remember we have this Yahoo stocks example. So we are going to use the same thing in this example. So I'm going to just say Spark shell. Start the Spark shell. And remember we were creating the data frame by reading the RDD and then converting it. I guess you guys remember. So we are going to do the same thing. Then let's do this manually. sc.text file. So you just read it and see what is there. The data is read. The Yahoo stocks example is already there. So I'm just going to run this again. You read the data, you extract the header, right? And then you convert it. And then you're defining the case class. Remember this? And then you will convert this to a data frame called stock price. So till this, I think it is here. It is called Yahoo Stock Data Frame, but we are calling it as stock price. That's also fine. Right. And you can register it as a table and then write queries. We have already seen that. That's not the problem. Yahoo Stocks Data Frame. Just a processing engine. Right. And therefore, let's create a Hive table using Spark SQL and store the data into the Hive table. So if you want to connect from Spark to Hive, you need to create something called a Hive context. So I'm just going to say, we're going to say stock price dot show. Okay, we have the data. So first thing that you need to do is that you need to create something called a Hive context. So I'm going to my Hive context equal to, you will say new org Apache Spark SQL Hive dot Hive context, and you will pass the SC. Right. So you are creating an object called a Hive context object, and you are passing the Spark context in doing this. Now you may be wondering, why are you creating this object called Hive context? This will allow you to connect with Hive from your Spark SQL session, right? So first step is that you create this object, and now we will use this Hive context for operations on the Hive table. So if you want to create a Hive table, you can simply say my Hive context.sql, and then you can simply say create table, the Yahoo stocks table that you want, right? So let's say you can say my Hive context.sql, and you can simply say the create table statement, right? So I can say create table Yahoo stocks one. Yahoo stocks, let's call it as 100, okay? Because probably the table will already exist. String open, that is float, high, that is again float, L means low value, float, and there is adjustment, that is also M is integer, then there is adjustment, which is float. So this is your query. So what it says, create table should work, right? Not two things. Yes. Yes. So once you create a Hive context, using the Hive context, you can say dot SQL, and then if you run a create table command, this will be created in your Hive actually. And now if you want to load the data, let's say into the Hive table, you can again use the same set of commands. For example, you can say my Hive context.sql load data. So let's say my Hive context.sql, I can say load data in path, and where is the location? You can say user training Yahoo stocks.csv. Yahoo stock 100. Yahoo underscore stocks 100, right? Not stock. It is stocks 100. Yes. See? So now it is loaded the data, right, into Hive. And we can actually go to Hive and verify this. So what I can do, I can create one more session and then log on to Hive. So let's start Hive and then verify this. Okay. Show tables. Yes, here is the Yahoo stocks 100. Select star from Yahoo stocks 100. Here is the data. Well, my data format was wrong. That is why it is dumping it as null, but you got the idea, right? So we didn't mention the delimiter in the create table statement. That is why it is considering each line as a column. Hmm? You should also say delimited by comma, right, in the create table. That is why it didn't understand, but you know the data is getting loaded. You got the idea, right, what to do. So this is one way to work with Spark and Hive. So what did we do? Let me show you this here again. You create something called a Hive context object. You can say new Spark SQL Hive context. And once you have the object from the Spark SQL command line itself, you can run all the Hive queries that you want actually. Okay. How can we read already existing table in Hive? I will show you. So the point is, this technique that I'm showing you, this creation of Hive context and all, is a bit old. Now, in your slide, actually, this is what we have. If I look at your slide, this is what we have. But this technique is a bit old. How do you know that it is old? I can actually prove it. When you're creating that Hive context, you will get a warning. So where was the time when we created it? See, let's say you're creating this Hive context, right? You will get a warning. Let me show you. See, warning. There was one deprecation warning, rerun with deprecation. So it is giving the warning saying that, you know, this creation of Hive context and accessing the Hive tables using this Hive context, these techniques are actually a bit old. In the latest versions of Spark, the Spark session itself supports all this. Let me show you that. So ideally what you should do, go to the Spark website, and then you have documentation. Let's pick up our version, that is 231. And in the documentation, if you scroll down, there is Spark SQL. In Spark SQL, you have run Parquet Hive tables. Very interesting. So this is what you should do ideally. And when I'm working, this is what I'm seeing. Most of the times people are using this technique. So Spark SQL also supports reading and writing data stored in Apache Hive, right? So that is what we are doing. Configuration is done by placing Hive site XML or core site XML in the Spark configuration. Now, how do you do this is very, very easy, actually. So you have to create a Spark session. Now, we already have the Spark session, so I don't have to worry about this, right? Now, if you want to read, all you need to do is this. So I can simply go here and I can simply say spark.sql and I can say select star from I think this should work. See, you don't have to do any of this like creating Hive context and doing this, that, and all. If you want to read a Hive table, very simple. Simply say spark.sql and whatever query. So this will directly read from Hive. I'm reading from Hive because this Yahoo stocks table is in the Hive. Now, what if your table is inside a database? So let's read it, right? We had a table, right? Retail DB departments. So you want to read that? So very simple. If you want to read that, all you need to do is this. Select star from retail DB dot departments. So some Spark versions have a bit of warning, don't bother about it, but you know, you are able to read it directly, right? So select star from DB name dot table name, and the data in the Hive table is now available as a data frame to you. So it is as simple as that, right? So look at this table. This it is able to read properly, right? you can get the department and the ID name, right? So in the Spark version 2, especially when you start with 2.2 and 2.3, what is the recommended way is that you can directly use the Spark session to read any table from Hive. So this is one thing you will be interested to know. The second thing you will be interested to know is that how can you save it back in Hive? I have a data frame. I want to save it back. So what was the name? Yahoo stocks, right? We created a data frame, right? Stock price.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and DataFrame? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now, let's continue with the session. Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
We need some data to play around with, right? Let me just verify. What I'm going to do, val ret equal to spark.read.csv, and let me just give the data. Oh, very nice. I think there is a one column data, some data that we have. I just read it, right? So there is a retail sample data in Hadoop. I read it into Spark. I say spark.read.csv. I got the data. Now my intention is I want to save it in a Hive table. How can I do that? Right. It's actually very simple. Let me show you. Yes. So you can simply say ret dot save as table, ret table, something like this. So sometimes you need to save, import certain libraries. I will tell you when you need to import watch, but let me just import these standard libraries. I will explain when to use watch. Import org.apache.spark.sql.save mode. Okay, now it should work. Hive records, read table. See, Hive records. It got saved as a table. This is the command I ran, right? The command I ran is this. So Hive records is the table name. So once you have a data frame, RET is my data frame. You can say write mode, okay, save mode overwrite. So what is this? When you're saving a data frame in a Hive table, you can mention something called a save mode. And there are three save modes: append, overwrite, and replace. I think the third one is ignore, right? Because in Hive, when you are saving the data, either you can append the data, or you can overwrite the data, or you can ignore the data. So when you are saving a data frame, so right now I'm saying that I want to save this data frame called RET. The save mode is overwrite. So if there is a table already, I want to overwrite. Simply say save as table, it will save it in a Hive table. That's all you need to do. So my whole purpose in demonstrating this is that use the Spark session for Hive integration. If you want to read the data from a Hive table, you can simply say spark.sql and then anything that you want. Any table in Hive and any query in that table will use Spark engine to read the data. If you want to store the data, permanently in a Hive table, say write mode, overwrite, or append, save as table. That is how Hive integration works. Okay, so let's discuss a little bit about performance tuning, right? Well, performance tuning may not be something which can immediately have an impact on your learning, because See, things like performance tuning will come into picture when you start working and you work for an year or two, and then when you want to dig deeper, because performance tuning is done if now your program may run in any way, but later you want to improvise on your program, right? So for some workloads, it is possible to improve the performance by either caching data in memory or tuning on some experimental options. Now, remember we discussed this caching technique in Spark in RDDs. The same thing you can use in Spark SQL, meaning you have a data frame, and let's say you are running a lot of queries on the data frame. You can simply say data frame dot cache. What will happen? The underlying RDD will get cached, right? So Spark SQL can cache tables using an in-memory columnar format by calling spark.cache table or dataframe.cache. Any of this is fine. So when you cache a data frame, what will happen? The internal RDD, which it is related to, will get cached. And if most of your queries are on the same data frame, it will be ideally faster. That is what is going to happen. Then Spark SQL will scan only required columns and will automatically tune compression to minimize memory usage and GC pressure. Right. So caching is a good technique. You can call spark.uncache table to remove the table from memory. So if you are registering the data frame as a temporary table, then you can say spark.cache table, right? This can be used if you are registering as a temporary view, create or replace temp view, right? If you're done with it, you can say spark.uncache table. That is also possible. And when you're caching the data in memory, configuration of in-memory caching can be done using setconf method on Spark session or by running set something equal to something. So when you want to cache it, either you can say set Spark SQL in-memory columnar storage compressed true, right? So when you do this, what will happen? Spark SQL will automatically select a compression codec for each column based on the statistics of the data. This is really helpful because if your data is in the columnar format, right, row column format, each column will be different, right? For example, we have some compression codecs, like there is something called ELZO, Snappy. These are all compression codecs, and they will work really well if you know how the data is. For example, imagine there is a column called a gender. There is a gender column. Now the gender column can have what? Maximum 3 values, unique values, male, female, or you don't want to provide the information at all, right? So the compression that you use in the gender column compared to, let's say you are compressing on a transaction ID column. Transaction IDs are what? They are having millions of unique values, right? So depending on the data that you have in a Spark SQL data frame column, Spark SQL will automatically use the appropriate compression codec. To do that, you need to simply say Spark SQL in memory columnar storage compress true. If you do that, it's gonna cache it and compress it as well. That is one technique that you can use. You can also say Spark SQL in memory columnar storage batch size to a value something like 10,000. It controls the size of batches for columnar caching. Larger batch sizes can improve memory utilization and compression, but risk OOMs when caching the data. So what is this property? This is the batch size. So if you say 10,000, the batch size is 10,000. So it will start compressing 10,000 batches, right? So if the batch size is really big, you may get a out of memory error. Otherwise, this is also a good technique you can use. Following operations can also be used to tune the performance of query execution. What is it? Spark SQL files maximum partition bytes. The maximum number of bytes to pack into a single partition when reading files. So what happens is that partitioning is also applied to Spark SQL, right? So when you're saying that I'm reading a JSON file or I'm reading a Parquet file or a CSV file, what is the maximum partition? The default is 128 MB because by default the partition is set to 128 MB. Now you may be wondering why this partition and all are really important. It is really important. In Spark SQL, we have a shuffle. So I will discuss it, the last property. Partitions are really important. And what is the second property? Spark SQL files open costlin bytes. The estimated cost to open a file measured by the number of bytes could be scanned in the same time. This is used when putting multiple files into a partition. Right. So why this property is important? So if you're having a lot of small files, then this property is important. Otherwise, it is not really important. So what this property says, it gives you an estimated cost to open a file, right? So for example, I have 1,000 or 2,000 files, and I want to read them, all of them together, right? So how much time should be allocated for opening and sampling and reading the file? That is this property. Spark SQL broadcast timeout in seconds for the broadcast wait time in broadcast joins. So there is a technique called a broadcast joins, okay, that we use in Spark SQL. Maybe not really important right now to you. So you can set a timeout period for that. That is this broadcast timeout period. And what is the Spark SQL auto broadcast join threshold? This configures maximum size in bytes for a table that will be broadcast to all nodes when performing a join. By setting this value to -1 can be disabled. Note that current statistics are only supported for high metastore tables. So probably this broadcast join is important for you. So let's say you have two data sets. So there is a file 1.csv and there is a file 2.csv. And you are saying join and you read it as a data frame. Okay. So you said df1 equal to this. And here you said df2 equal to this, right? Now you are saying that join df1 comma df2. You are writing a join operation, no problem. This file 1 CSV is, let's say, around 20 GB. File 2 CSV is, let's say, 40 MB. Small file. So the point is that if I simply say join data frame comma data frame 2, the join operation will happen, no doubt about it. But if I want to make my join operation more efficient, I can do something called broadcast joins in Spark SQL. So you just need to use a keyword and then it will do something called a broadcast join. What is the advantage of doing a broadcast join is that when you do broadcast join, so this data frame 1 is 20 GB, right? Imagine data frame 1 is lying on 33 machines. Because it is a very big file, it is divided into what blocks, and let's say the data is lying on 33 machines. Data frame 2 will be normally lying on only one machine because it is a very small file. When you do a broadcast join, what will happen? It will take the smaller file, that is this data frame 2 file, and broadcast it to all the 33 machines where data frame 1 data is there. So your joins are faster. So basically the smaller file is taken and then it is broadcasted to all the machines wherever there is a part of the bigger file. So your join operations, we have seen, becomes 2 times, 3 times faster. This technique is called broadcast join. And what is this property? It is telling you what is the broadcast join threshold, right? So if you say 10 MB, the threshold, if your second table is less than 10 MB, it will be broadcasted. If it is more than 10 MB, it will not attempt broadcast join. So ideally, we can keep it less than 100 MB. So like 40 MB, 60 MB, the threshold, that will speed up your join. But if it is too big, that is also another problem. Like if your file is like 3 GB, you cannot broadcast to all the machines. That will again have a lot of performance issues. And this broadcast timeout is, you can set a timeout. And after that, if the join did not complete, it will abandon it. Actually, the last property is called Spark SQL shuffle partitions. This configures the number of partitions to use when shuffling data for joins or aggregations. And this is very important, right? It's very common that you have something called shuffle operations. Like you are going to join two tables, right? If both the tables are really big, and when the join operation happens, a lot of data shuffling will happen, right? And that is very common. During the join operation, it will happen. Now, this property set how many partitions maximum you should use for your shuffling and join operations. And ideally, the default number is 200. Sometimes we keep this number even more than 200. That is recommended actually, right? Because Spark SQL also has a small drawback. If the partition size is more than 2 GB, your shuffle operations will fail. We always see this error. So the problem is, let's say you have a 10 GB file. Okay. And let's say you created a data frame. You said df equal to spark road read.csv. And then you read the file.csv and you created it. Now, what is the size of the file? 10 GB. Imagine that you read it as two partitions. So what will happen? You will have partition 1, that is 5 GB. Then you will have partition 2, that is again 5 GB. Now this is fine. I mean, you may think this is fine, but the problem is that when a shuffle operation or a join operation happen, it will throw an error and it will not work. Why? Because the partitions, if the partition size is more than 2 GB, it cannot support shuffle or join operations. Then what will you do? You can say repartition. There is a command called repartition. So already my data has two partitions. I can say repartitions 10. What will happen? Your data will get repartitioned to 10 partitions. So these are some of the things which will become very clear to you when you start working. Maybe not immediately you will understand this, but the size of the partition, the number of partitions to be used, these all have a very strong impact on your performance.
There are a lot of things you have to understand before you get started with Spark hands-on. Writing Spark programs are actually very easy. It's not so difficult to write a program, then run it and get it. That's not what is difficult. What is actually difficult is to understand what is happening behind the scenes, right? Okay, so I have connected with you know the VM. Now, one thing you need to understand is that Spark offers an interactive shell in Scala, Python, and R. So if you want to program in Spark, you can open a shell and then type your stuff, right? Very much like you were doing in the Scala world. You were opening the Scala prompt and then you were typing stuff, right? Now, the second thing is that Spark also allows you to package your source code and run it. So this is the second way. So one way is that you open a shell and then type your code step by step, blah, 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 right? The second thing is that you can also write your entire source code in a file, then compile it, package it, create a jar file and run it. I will show you both things, okay? But most of the times we will be working from the shell. And that is the easiest way to understand Spark. If I go to the packaging mode, I will have an application which will get packaged. And I can show you how to run that, but you may not be able to understand everything, right? So most of the time, we will prefer the shell, at least for learning Spark. Once you master Spark, if somebody asks you to create a Spark application or something, you can write a code and package and give it to them. Now, the next question is that how to start the Scala shell for Spark, right? So I want to use Scala. Obviously, we know Scala. Now, we know that there is a Scala shell. Now, how do I start it? What is the command or how do I start it? And what are the things which will happen, right? So now starting this is okay, but then still there are a couple of things you need to happen. The command is Spark -shell. This is the command. So you have to type a command called a Spark-shell and then Spark will start in the Scala prompt. Now I can show that if I go here, I'll simply type Spark-shell. That is a command I wrote in the one notch. I hit enter, Spark will start. Just wait for a moment. Yeah. See, so when I type the command Spark-shell, it started the shell. And there are a couple of things you have to make a note of when you are starting the Spark shell, right? So one thing is that you can see the version of Spark. It clearly says that the Spark version is 1.6.0 and the Scala version is 2.10.5. So these 2 points you have to make a note of. And in your VM, when you start, I don't know whether you're having the same version. Maybe you have a different version, but it is fine. You know, the versions are fine. You don't have to really worry about them. Maybe you will run 163 or 15 something. But when you start this Spark, you will be able to see this version number. And also what is the Scala version Spark is using. Now, Spark has 2 major releases. Okay. So Spark has 2 major releases. They are called a Spark 1 and Spark 2. We are on Spark 1 and there is a reason. Okay, Spark 2 is quite new, even though Spark 2 is very stable. If you look at the industry, right, most of the companies are still using Spark 1. They have not migrated to Spark 2. And there is from command wise, let's say you are learning your commands or the program, there is only a slight difference between Spark 1 and Spark 2, which means whatever you are learning in Spark 1 will easily work on Spark 2 as well. So you don't have to really worry about the syntax or the commands and all. However, Spark 2 has a lot of performance improvements compared with Spark 1. It is actually better, but I don't want to use it because as of now, most of the industry is on Spark 1.6, and this is a very stable version, right? So we will learn this, and whatever you have learned, you can use them in any other Spark version as well. Now, if you want to understand the versions, just go to spark.apache.org, and if you go to the documentation, there is older versions, okay, and these are all the versions we have. We are on Spark 1.6.3. Okay, after that there is 2.1 and 2.2 as of now. Okay, however, any Spark 1 is perfectly fine with us just to learn, right? So this is another point which I just wanted to clarify. That is why you see a 1.6.0. Even this is my virtual machine, even your VMs will have one of the Spark 1 versions. Okay, and then it starts. And how do you know whether Spark has started or not? Is that you will see this Scala prompt, right? You will see this Scala prompt. That means Spark has started in the Scala interactive mode, and you can start typing your code or whatever you want. Okay, and you can simply type an exit, and you will exit from the shell, right? So if you simply type exit, you will exit from the shell. Okay, so I will again start the shell because I just closed it. Okay, now one thing you need to understand is that if you want to work with Spark, you need a driver program. So any application, you need a driver program, right? So even with Spark, let's say you want to work with Spark, you need a driver program. By default, your shell will become the driver program. So when you start the Spark shell will be your driver program. So you don't have to create a driver program. That's my whole point, right? Whatever you are typing, your shell will interpret and make sure that it will run. So you don't have to worry about a driver program while starting the shell. The shell will become your driver program. Okay. And the next thing is that in core Spark, there are three building blocks for your program. Meaning, when somebody is creating a Spark program, there are three things which are very, very important. Okay. One is called something called Spark context. Second is called RDDs. Third is called transformations and actions. So these are the three things you must have if you're creating a Spark program. Okay, so in this, the first thing is called a Spark context. What is this guy, right? This is an object used to access Spark libraries. Okay, so what is Spark context? Spark context is an object. Okay, and when I say it is an object, what is the purpose of this? See, we just started Spark, right? So here you have the Spark shell, right? And this is a Scala prompt. So if I type something here, what will happen? My Scala will interpret the code for me, right? I type anything, I say for example, I type 1 plus 2 or anything, what will happen? I will get the answer, right? So let me just show you this.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD, B. DataFrame, C. Dataset, D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
See, if I do a 1 plus 2, okay, my answer is 3. Okay. Now, do you think Spark is running this code or Scala is running this code? What do you think? I typed 1 plus 2, I got the answer. Again, I say 5 plus 5, I got the answer. So, who is running this code, Spark or Scala? It is Scala, right? It is just a Scala shell, and you are getting the answer from Scala. So, now the question is that this means if I type anything here, Scala will execute that for me. I don't want that. I want Spark to execute my code. Spark is already there, but I want Spark to run my code. So how do I tell that, hey, Spark, run my code? That is using this thing called Spark context. It is an object. So you have to use this object whenever you want to access Spark from the shell. So this is the entry point to the Spark libraries, right? And I will show you this. So now the next question will be that how do I get this object? You don't have to worry. When you start the shell, it will be written here somewhere. See? Spark context available as SC. So what will happen when you start the shell will create something called Spark context object as SC. That means if I call this object with SC, the name SC, I can connect with Spark library. Anything I want to do with Spark, I have to say SC dot. That is how I access Spark. All the Spark method, functions, anything you want to access, first time you have to use SC. Otherwise, your Scala will execute it, right? And that is something we don't want, right? We don't want Scala to run our program. We are just using Scala. We want Spark to run our program. And that is why we are using this SC or Spark context, okay? The next point is that Spark shell can be started in two ways. Okay, there is a local mode and there is a yarn mode. Okay, so when I say I'm starting Spark or the Spark shell, right, it can be started in two ways. There is something called a local mode and then there is something called a yarn mode. Okay, so what is local mode? This is the default mode. That means we are in the local mode. We started Spark shell. We are in the local mode because this is the default mode. Here, okay, Spark will run locally on the machine. It will ask the OS operating system to get the resources. Okay. Also, entire code will get executed within a single JVM normally. So what is local mode of Spark? What we started right now is the local mode. This is called the local mode. When you start Spark in the local mode, it will start on the machine. So right now the virtual machine, right? And it will start and it will ask your operating system for the resources. For example, right now I have a Linux as my operating system. It will ask the operating system, hey, give me some resources to run this Spark program, right? And the local mode and this mode will work only on a single machine. That is the point. Local mode will work only on a single machine. You cannot expand it. Then why do you need the local mode? For testing, development and learning. So if you want to learn Spark, probably the best way is the local mode, right? What is the yarn mode? Here, Spark will use yarn to allocate resources and run the code. This means it can run the program in a cluster that is hundreds and thousands of machines, right? So when you start the Spark shell in the yarn mode, I will show you how to do that. Okay. What will happen? Your Spark will register with yarn. If yarn is available, if you have Hadoop. So Spark will tell yarn that, hey, I am Spark and I want to run the program. So yarn will say that how much resources you need. Spark will probably say that I need 100 machines, and yarn will give you 100 machines. So that is the cluster mode. Okay. So the production mode is the yarn mode, but for learning, local mode is fine. In fact, both the modes, while running the commands or syntax or anything, both are exactly same. You will not even see any difference, right? Only difference is in the execution. Yarn mode is used if you are having a cluster, because in a cluster, if you want to utilize the full power of a cluster, you need a resource manager, and that is your yarn. Remember how you can run a MapReduce program? If you submit a MapReduce program, your yarn's resource manager will pick it up and run it, right? Same way, your Spark shell can register with your resource manager, and it can run it on a full cluster. The yarn mode can run on a single machine also, and that is what I will show you. Okay, so we are in local mode right now, so that is one thing you need to understand. We are in the local mode. So now what we did, we started this Spark shell and blah blah blah. Also, one more very interesting thing you can note down here is that when you are starting this Spark shell, it says Spark context available as SC. It also says master equal to local. Very interesting stuff. So this is how you understand that it is in the local mode. Master is in master equal to local means you are starting Spark in the local mode. Otherwise, how do you know, right? And I will explain what is that star means later. As of now, don't worry about the star. Okay. So while starting the Spark shell, you can clearly see master equal to local, right? Now, one more thing is that in local mode, Spark UI will be available in IP address :4040. So Spark has a UI, a user interface, okay, and you can easily see the UI if you type the IP of the VM and the port number 4040. Can I show you that? Yes. So if I open my VM is 131, and simply type 4040. That's the Spark UI, right? What you see here is the Spark UI. And as of now, you are not seeing anything, because the Spark UI will display something only when you execute something. Remember, Spark is very, very lazy, right? So you have to write some transformation and action. And when you call an action, then only it will display something on the UI. As of now, there is nothing. There is something called stages and storage. I will explain all this later. You can see the environment where you see the Java version, Spark version, and all. And executors, SQL, nothing much to see right now. Anyway, right? So that's the Spark UI. Now, the first thing that you should learn in Spark is how to create an RDD, right? So, how to create an RDD, right? So there are two prominent methods to create an RDD. One, you can create an RDD from an existing collection. Two, you can create an RDD from an external file. So there are two ways to create an RDD. The first way is that you can create an RDD from a collection. What do you mean by collection? Say you are having list, array, anything like that. So you have an array, you have a list, and you want to create an RDD, you can do that. So here you will use a method called parallelize. Okay, so parallelize is a built-in method. Okay, and you will use this method if you want to create an RDD from an existing collection. To give you an idea, okay, val a equal to sc dot parallelize 1 to 1000. I just created my first RDD. How did I do it? Well, first thing you need to understand is that the name of your RDD is A. You can give any name you want. So the name of the RDD is A. Second thing you need to understand is that I am saying sc dot parallelize. So remember what is sc? Sc is your Spark context. So you have to talk to Spark library to create an RDD. So you will say sc dot parallelize is the function which will create the RDD. And this is my data. My data is nothing but numbers 1 to 1000. I just want to convert numbers 1 to 1000 into an RDD called A, and this is how I do it. So I will type the commands in here so that you will understand it. Okay, and you can clearly see that Spark says A is an RDD of integer type. So there is automatic inference. It says that we have created an RDD and it is of integer type. Now, second thing you need to understand is that in an RDD, Spark always treat it as a collection of elements. For example, here you are saying that I have numbers 1 to 1000. Okay, fine. This means what Spark will understand. Spark will understand that the RDD has 1000 numbers and each number is an element. That is how Spark will treat it. Now, if I look at the UI, Spark UI, I will not see anything here because I have not called any action. I just created an RDD and nothing will be displayed here. If I want to see something, I can do an a.collect. Collect is an action. Remember in the slide also I had explained about collect. Collect is an action, and what collect will do, it will simply display the output, or it will simply display the content of an RDD. So right now I am saying that, hey Spark, display the content of A. And Spark is very intelligent. It will not display all the data. It says 176, so on and so forth. I mean, etc., etc., right? And the results are always displayed inside an array. So this array is default. Spark will create an array and throw the result to you. So we see very interestingly that we call an action a.collect, and then you can see the output. So you can do a.collect, right? Now, another interesting point. Remember I told you that whenever you're creating an RDD, right, it will divide the data, partitions, right? So when you're reading from Hadoop, this is easy because in Hadoop, what your Spark will do, it will treat each block as a partition. So if your data is divided into, let's say, 10 blocks, Spark will create an RDD with 10 partitions, no doubt about it. But right now, my data is not in Hadoop. When I say 1 to 1000, the data is not in Hadoop. Okay. So the question is that in this RDD called A, how many partitions will be there, right? So we will look into that. You can also create other RDDs. You can say sc dot parallelize, okay, and then you can say I have a list of elements like Hadoop, Spark, MongoDB, Python, Scala. So again, here I'm creating an RDD. So this is my data. It's a Scala list. And I will again call the sc.parallelize method on that.
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Right? And I get the RDD. And if I do a b.collect, I have the data. No rocket science, something very simple, right? So let's again run the a.collect. Okay. Now I want to know how many partitions this RDD is having. So you can simply do a dot partitions dot length. And when you look at the length of partitions, it says 2. So Spark is telling me that there are 2 partitions for this RDD. And I will tell you why. And you can see that in the shell. So if you refresh the shell, the UI, you see the Spark jobs. So you see 3 collect statements, okay, that we ran. And this is the latest collect statement. And if you look at this collect statement, okay, it says 2 by 2. Can you see here? A number 2 by 2. So the first 2 indicates the partition. The next 2 indicate the task which we're running. I mean, what Spark is saying is that there were 2 partitions for the data and your task run on each partition 2 times actually. So the default number of partition in here is 2. The question is that why it is dividing your data into 2 partitions, right? To answer that question, it's very simple. If you look at my VM, this is my VM. So I am having 2 processor cores, and that is why it is creating 2 partitions, okay, of my data. Now, the more partitions you have, the more faster your program will run. The idea is that the more partitions you have, more faster your program will run. Ideally, what will happen? Each partition will be, when you run the program, right? A processor core will be allocated to each partition. So if I create only one partition, only one processor core will be allocated for the whole data. And it will be very slow. So in real-time data, so your data will be spread across, let's say, 20 machines or 30 machines. So each machine will hold a partition, and the more partition you have, the more faster your program is going to run. Okay, so this means the number of partitions are 2. We understand that. But the next question comes, is there a way I can change this? By default, it is 2, but can I change the number of partitions? And yes, you can. If you want to change the number of partitions, let's say you want to create a RDD with 10 partitions, do like this. So all you need to do is an SA parallelize 1 to 1000, comma 10. See? And then if I do a dot collect, sorry, a dot partitions dot length, you see it is 10. And if I do a dot collect, I get my data. The data remains the same, but while creating an RDD, you can manually mention the number of partitions as well. This has to be done by considering the resources in a cluster. As of now, don't worry about manually mentioning the partition because we will not be doing that. We will leave this thing to Spark to figure out the number of partitions. That is the best way. But in some of the advanced programs and conditions, you might want to tweak the number of partitions, which you can do. That is all I wanted to show. And if I look at the Spark UI right now, you see this job is having a 10 by 10, right? So this indicates it was running, with 10 partitions. And clearly have a look at here. Look at the duration, the time taken to run the program. Do you see anything interesting there in the duration? The more partitions you use, the faster your program will run, ideally. Okay. So when I was using 10 partitions, it was 0.1 because, it's like parallel processing, right? So it becomes faster, ideally. But anyways, we are just not interested in that right now. I will exit the Spark shell. Okay. Now, how to start this Spark shell in the yarn mode, right? So we have this yarn mode, right? So the local mode, you know how to start. You simply type Spark shell. In order to start Spark in the yarn mode, what you need to do is that you have to say Spark hyphen shell hyphen master yarn hyphen deploy mode client. So this is the command. I'll just copy the command. I'll write it here probably. To start Spark in yarn mode, use this command. So what is this command? You will say Spark shell, that is same. You will say master is yarn, deploy mode is client. That is how you start. And same thing will happen. I mean, the Spark shell and all will remain the same. The commands also will remain the same. But this time, the Spark shell will register with your resource manager. I will show you that. Let it start. It's taking some time to start. See, comparing with the local mode, it is slow because yarn is actually slow, right? You are using the resources allocated by yarn and it will be very, very slow since you are running in a VM. Okay, Spark started. You can see the shell, and here you can see that Spark context is available as SC and master is yarn client. Previously, master was local. Now it is yarn client, which means it is running in the yarn mode. Now, in the yarn mode, if I look at the UI, I will not see the UI. So if you type, okay, so this is redirection. Okay. So in the yarn mode, if I want to see the UI, okay, what I need to do is access your resource manager. So this is the Hadoop resource manager, and I think you are aware of this. I'm aware of this, right? The Hadoop resource manager will be by default running in port number 8088, and look at the application that is there using it. The application name is Spark Shell. Can you see here? Application type is Spark, and if you click on this application ID, okay, you have this application master. Remember in Yarn, when you launch a program, it will create something called an application master. If I click on this application master, I have the Spark UI. So the point is, when you start this Spark shell in the Yarn mode, it will register with your resource manager. That means you have to open the resource manager UI to see Spark. That's what. So now the next question is that the one way to create an RDD is from a collection. The second thing is that you can create an RDD from an external file, and probably this is something which you need. So let's say you have a file, a text file or a CSV file or any file that you have. Probably you want to create an RDD from the file. How can you do that? Here we will be using a method called text file. So text file is a method we use to create an RDD if you want to read from a external file. So to show you that, what I'm trying to do here is that I will access my Hadoop. I will start my Spark shell. So I will access my Hadoop, and if I go to my Hadoop, there is a file called a book.txt. Let me show you that. Okay. So there is a file called a book.txt. I'm just highlighting the file. It is a book actually, some book. I don't know even what book it is. Now, what if I want to create an RDD from this file, right? Very simple. All you need to do is let it start. Come on. All you need to do is that simply say something like book equal to sc dot text file. That's a method. And then you will say simply book.txt. Why am I typing only the name of the file? Because it is in my home directory in Hadoop. Otherwise, you have to give the complete path. Since it is in my home directory, I just have to give only the file name. So you simply say sc.text file and then the file name. It will create an RDD. Give you this command. And when I do a book.collect, it shows the result, right? Again, it is displayed inside an array, but we can clearly see some lines from here. Okay, so that means we are able to get it. Now, collect is one action, right? What are the other actions you can run? You can do a book dot, okay, first. Can you tell me what this command is doing by looking at the output? What will this action do? Book dot first. Exactly. It will read the first line, right? It will read the first line. Now you can also do a book dot count, and it will count the number of elements in the RDD. So here an element is a line. So it's counting the number of lines, 12,760 lines. You can also do a book dot take and a number. So first, count, take, all of them are, all of them are actions. Now, one more thing that people are always asking is that, okay, I want to collect, but how do I save the output? If you want to save the output of an RDD, you can do many ways actually, but the easiest way will be to save it as a text file. So what you can do, you can say book dot save as text file. This is the method, and then simply give a folder name. What will be the folder name? Something like this. So this command will save the RDD, okay, in a folder called ABCD. ABCD is the folder name. And where is this folder? It will be in Hadoop. If I go back to Hadoop, user, Cloudera, there is ABCD, and here is the output. But it is storing as two part files. And this is actually the book. There is some formatting issue, but you can see here the actual book, right? So yes, you are able to save it. Okay. Why two part files? Because you are running two partitions. Each partition will save its own data, and that is why you get two part files in here. Word count problem using Spark. So first thing that I have to do is I will be using this book.txt, the data set that we have. Where is it? So we have this book.txt, and like I said, it has around 12,000 lines of data. So I thought that this will be a nice input file for running our word count program, right? So we will use this as our input data set, and then we will see. Okay. And the first thing you need to do is create the RDD. So I will type it again. Book equal to so step number 1, read the data and create the base RDD. What do you mean by base RDD? That is the first RDD you will be creating in any Spark program. And this is our base RDD. Okay. And we will just ensure that we can see it very well. So it's working fine. If you look at my RDD also, this RDD has lines of data. For example, this is one line of data. Where is it? So this is one line of data, or probably this is another line of data. So this is the first line of my data. The project Gutenberg ebook of the outline of science. That is my first line of data. And what I should do, I cannot do anything with a line of data. I have to get the individual words first. First thing you need to do is that you have to extract the individual words. And remember the map transformation we were talking about? Probably the map transformation is a good way. So let's say we create an RDD called A, where I will do a book.map. I will say that take every line and split it using space. Now this command should be familiar to you because we have already seen the map transformation in Scala. So the same map transformation can be used in Spark. Map is a transformation actually in Spark. So what I'm telling here is that, hey Spark, take the RDD called a book, apply the map transformation to every element. An element is a line, right? And I'm taking that, take every element X. X is a line, split the line using space. We are assuming that the delimiter is space, and that's it. So ideally, you will expect that if you do this, you will get each line and the line will be having individual words. So A is my RDD, which contains the uh, individual words, which should ideally contain the individual words. But when I do a dot collect, the problem is it took one line. Look at the first line, the project Gutenberg ebook of the outline of science. So this is the first line. It took this line and it extracted all the words. See here, it extracted all the words. Okay, like this. Okay, I think it is still volume 104. So this is one line. It extracted all the words. You can see the, then project, then Gutenberg, then ebook. But the result is stored in an array. So we have an array of arrays. That is not really good for us. Since the map transformation will work on individual elements, that means individual lines, for each line, the output will be an array.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and DataFrame? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now, let's continue with the session.
And all of this you are doing in an RDD. So there will be an outer array and list of arrays inside them. That means from this, right, it is difficult to get the individual words. All I want is words. That is why you should not use map in such scenarios. I just showed you a map to tell you how the output will look like. Ideally, what you should do is that you have to do a flat map. So look at what I have done. Instead of using the map transformation, I am now using another transformation called flat map. And you will understand what is flat map if I show you the output. If I do a dot collect now, look at the difference. Do you understand? Just by looking at the output, I think you will understand. So what is flat map actually doing? It will flatten your result so that you will get all the words in a single output. So now we are happy because we got the words here, right? So I will just write it here. This is your second step. Okay. Second step is extract individual words, and you will do it like this. Okay. So now remember this point, you have an RDD called A, and in the RDD called A, you have all the words. Okay. RDD A has all the words. Look at the anonymous function I have written. So here it can be anything. It can be X, Y, Z, J, anything. I am saying that take every element and convert to something like this. Probably if I do a B dot collect, you will understand. Just look at the output. You are taking each element or each word and converting that into a key value pair. I mean the word comma 1, right? If I write it, fine. So we have reached till this point. Now the final stage. I will just write it, then I will explain. Don't worry. So I did something, whatever it is. I did a command, b reduced by key, blah, blah, blah. But if I do a c dot collect now, I have the final answer. See, this is repeating 28 times. Iron is repeating 20 times. Constant is repeating 2 times. Born is repeating 3 times. Whatever I did in the RDD called C, I have the final answer. But the question is that what did you do? So step number 4 is get the final answer. And to do that, I have typed this. Okay, so this is the command I typed, and I will explain what is this command. I will explain what is this command. Okay. So this is a very interesting transformation. It is called a reduce by key. Okay. The transformation is called reduce by key. Now, what you need to understand is that by default, when you use reduce by key, it will assemble all the values of a given key. Okay. So what am I saying here? I'm saying that if you use reduce by key, it's going to assemble all the values of a given key. So let's suppose our data in B was like this. So B was our original data. So let's say the data was this comma 1, this comma 1, this comma 1, and this comma 1. Okay. So the original data in B, okay, the original data in B was like this. Okay, this one, this one, this one, this one. Imagine. Okay. Now you are saying that reduce by key. So reduce by key will assemble all the values of a given key. This is like the shuffle phase. In MapReduce, you have a shuffle phase, right? In shuffle phase also what happens, it's going to get the key and values similar, right? And in here, you are writing a very special anonymous function. You are saying that x comma y, rocket symbol, x plus y. This is what you have written. Okay. So what is the technical definition of this? Here, x and y are any two values. So we have four values, 1, 1, 1, 1. X and y are any two values. The expression says take any two values, x and y, and add them. Also, keep on doing it till the values are over. So to make you understand, this is a special way of writing the anonymous function. We say x, y, x plus y. This simply means take any two values and add them together until the values are over. What is going to happen? Your values are like this, right? The values are 1, okay? Then you have 1, then you have 1, then you have 1. These are the four values, right? Now, initially, x will be this and y will be this, okay? Now, what will happen is that you are saying that take x and y, do x plus y. So, if I apply this logic here, if I apply this logic here, I will get the result as 2 because 1 plus 1 is 2. Okay, and now your data will become like this: 2, 1, 1. Okay, and now your x will become this and y will become this. Again, you will iterate the expression, right? So this expression will run till your values are over. Okay, I will get result as 3. And now your values are changed. You will have 3. Okay, so you are adding 1 plus 1, 2, 1, 1. Then 2 plus 1, 3 and 1, right? Again, x will become this and y will become this, right? And again, you iterate through this. I will get 4. Meaning you will finally get this comma 4. And since this will run for every key, you will get the final word count. So you can also say something like this. For example, you can say x comma y, do this. Okay, you can say x divided by y. So this is another expression. If I run this expression, it will keep on dividing. It will take the first two numbers, divide them, and the result again it will divide by the third one, it will keep on doing division until all the numbers are over. Right? We were adding, and you can also do division, you can do subtraction, you can do anything using this expression. But this is how the expression works. So I will get the result, and obviously one more point is that you can do this. For every x, you'll say convert to x comma 1 dot reduce by key, and then you can say take the values and simply add them together. That's word count in a single line. This is single line, entire word count program. It's easy in the way like first of all, the size of your code is very less, right? So that is the first thing, right? The size of the code is very less, and also running that is also faster. Obviously, Spark is faster than MapReduce, right? Remember, you used to run the word count program. You'll create a jar file, deploy it, and even if your data is very small, it will take a lot of time to run it using MapReduce. Okay, so that is one thing. Now, one more point in here is that even though the data looks really nice, okay, even though the data looks really nice, we have some problems. The output is okay, but we have some problems. What is the problem? For example, if you look at this p-value pair, it is saying that influences dot is a word, which is not the word, right? The actual word is influences, but since it is separating each word with space, it is counting influences dot as a word. And again here, if you look, it is counting vendor semicolon as a word, which is not really good. So can we make the word count program a little bit better? Yes, you can do it. What you need to do is, you can use a regular expression. So this is a regular expression I am using. I am asking that split it using proper words. And as you can see, the results are sort of much more refined or cleaned, right? So they are not like previous. The results are sort of like more refined. Your encyclopedia and all are gone, I believe, right? Because there was some special character, I think it will get rid of that, right? But apart from that, it looks very nice. Still, there is a lot of cleaning that has to happen. For example, there is a word called underscore Jurassic underscore. See here? So this word is bad. But let's forget that for the time being. If you get rid of the underscore, the rest of the things are kind of like happy, right? So the results are clean. Word count with regular expression is this. Okay, so this will be much more cleaned up. And now we have lot of what you say transformations to look at, but I will just stick to one more important transformation, because that will be useful in this problem. So what if I want to sort the output? Sorting, right? What if I want to sort the output? Okay, so if I look at the output, it's a key and a value. Okay, you can sort based on the key, you can also sort based on the value. However, if you're doing this, we will use a special notation so that you will understand, right? The sorting side, right? So first thing I am going to do is that I want to sort it based on the key. Okay. So what is the key here? The key here is the word. So I want to sort the data based on the word. And when you sort based on the word, it will become alphabetical, obviously, right? And in Spark, when you do sorting, the default is ascending. That means A, B, C, D up to Z. You can also do descending, okay? But the default sorting is ascending. So I will write it here. Sort the output based on the key. That is the word we have, right? Well, that's okay. But the real question is that you can say sort it, but how do you tell Spark that you have to sort it based on the key? So my question here is that what is an element in this RDD? So by looking at this RDD, so this is the result, right? This is the RDD. Can you tell me what is an individual element in this RDD? What is an element in this RDD? We say this RDD is a collection of what? Key value pairs, right? So this RDD is a collection of key value pairs, correct? So an individual element in this RDD is a key value pair. This is a key value pair. Intimately, comma 2 is a key value pair. Okay. So an element here is a key value pair, obviously, means this RDD is a collection of key value pairs. And that's something you have to understand. Okay, no doubt about it. Now you have to say, okay, sort the data based on the key within the key value pair. This is what you have to tell Spark. You have to tell Spark that, hey Spark, access an element first, and within the element you have a key, and sort it based on the key. So you will tell that so the element is simply key value. Then within the element, okay, use the key to sort. This is what you have to tell Spark. Now, in order to do this, I will write the code, then I will explain. I will say that sort by underscore 1. Answer is there. I will copy the code. This is the code I wrote. Okay. The thing that I added here is sort by. So sort by is a method we use for sorting. But I used a special notation after that. I said underscore dot underscore 1. So this is what I used. And this is something which is a bit confusing. Okay. Here, the first underscore means an element in the RDD, which is nothing but a key value pair. The second underscore means, okay, an element within the key value pair. Okay, So _1 means the first element in key value pair, that is the key. So when I say underscore dot underscore 1, first underscore means an element in Spark RDD. That is nothing but a key value pair. So I am saying that access a key value pair. Within that dot underscore 1, within that the first one, that is the key. Basically I am saying sort by key. Well, functional programming can be a bit hard for the first time to understand, but yes, right? So you are saying that take a key value pair, any key value pair, and within that access the key, and based on the key I want to do sorting. That is what you are saying. And if you look at the output, okay, you are getting these numbers because in the ascending order it starts with numbers, then only come A, B, C, D. And if you want to do descending, all you need to do is that you will say _1, false. See, you will say underscore dot underscore 1, false. When you say false, it will say descending order. And as you can see, it starts with Z, zoo types, then zoologist, you, yolk, blah, blah, blah. So this is descending order. Sort by key in descending order will be this. So same thing, you will say sort by key, false. False means descending order.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD, B. DataFrame, C. Dataset, D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session. Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So see, the idea is very simple. When we broadly discuss big data processing, we usually say there are two kind of processing. One is called a batch processing, right? And then, so I'll probably write it here somewhere. So we have something called batch processing. So in batch processing, what happens is that, you have a data set, you write a piece of code, and it is no longer real time that the processing. That is why it is called a batch processing. A common situation will be that imagine you have an RDBMS system, right? And there is data getting stored in an RDBMS system. And end of the day, I want to find out, let's say, what are the total number of transactions happened, total amount credited, so on and so forth. Imagine you're working for a bank, right? So in the bank, what happens? The transactions happen every day, right? And at the end of the day, you have to close it, right? So you do something called EOD, end of the day processing, right? What are all the, how do I say, transactions which happen during daytime? At the end of the day, you read all of this, you process it, you store it, you will also do some basic analysis if you want, everything. So what is happening is that the data is getting stored over a period of time, and later you are doing the processing. It can be daily, it can be weekly, it can be monthly. So an e-commerce company would like to know, somebody like Amazon, which type of, let's say, mobile phone was sold the most last quarter. So when they want to look at it, let's say Amazon would like to know which brand of mobile phone was sold the most last quarter. So when Amazon would like to know, all they need to do is look at all the transactions happened in the last 3 months, right? And then write a query. It can be SQL, it can be a program to figure out that. So the interesting point here is you have already collected the data, right? The data is already being collected and the data is already being saved in some place, right? All you need to do is figure out what kind of a program you need to write on the data. And so far, what we were doing is batch processing. So far, if you look at in our course, whether you're talking about RDDs, whether you're talking about Spark SQL, or let it be MapReduce, let it be Apache Hive, all these are classic examples of batch processing. And Hadoop itself is designed as a batch processing system. If you read the original definition of Hadoop, it would say that Hadoop is nothing but a big data batch processing system. Why? Because on those days, in the earlier days, when you look at big data, it was practically impossible to talk about real-time processing. All that we were able to do was batch processing. And this is not a new idea. If you look at mainframe computers, they do batch processing, and batch jobs are very common, right? But what we are really going to discuss is the other section called real-time processing, right? Or it is also called streaming. There are many names for this. It's called streaming, it's called real-time processing. So, hey, what is the difference, first of all, when you say real-time processing? The classic difference is that you process the data as soon as the data arrives. You are not going to store it. That is the classic difference between batch processing and real-time processing. I'm getting the data, and as soon as the data comes into my system, I'm going to process it. And I want to make some sort of a business decision based on real-time data, right? So you may probably wonder that, okay, so are you saying that the RDBMS systems or NoSQL databases, they do real-time processing? Not really. That is not what we call as real-time processing. Well, they work in real time, we know that. So if you look at an RDBMS system, it is completely transactional, it follows ACID properties, and it works 100% in real time. But all the RDBMS system does is store the data or insert, update, delete, or whatever you are doing, right? You are not really analyzing the data. You're just making sure that the RDBMS is efficiently storing your data. On the other hand, my requirement is given data in real time, I don't want to store it anywhere. Okay. I want to process it as soon as when it arrives. Now, this may seem very simple, but it is not. Look at the challenges. First of all, you are not sure how much data is going to come in. That's one problem that we have. Second, you need to process and the processing has to catch up. For example, if you're getting really good amount of data in real time, if your processing becomes really slow, then it is no longer real-time processing, right? So your system should be capable of processing this really fast. And you cannot have any kind of failures. Failures are not at all accepted because if you fail, if your system fail, you are missing real-time data. Well, you're saying theory, theory, theory. Can you give me some practical example of what we're talking about? Some business use case of what we're talking about? Yes, I can give you 3 examples where I have worked myself, which will give you an idea about what we're talking about, right? So there are 3 use cases which I personally would like to talk about. One is from the e-commerce industry, e-commerce. Second is this banking. Third is advertisement. Well, there are plenty of examples. These are my experience. So in the e-commerce industry, what we do, I was working with Flipkart, not now, like in 2015 and all, as a consultant. So I was looking at, I was observing what they were doing, and in e-commerce industry, there is a real interesting thing that happens. For example, I think The sale is on now in Flipkart. Flipkart runs a sale, and I think they have a sale now. Let me just check. Yeah, so there was a sale on Flipkart which ended yesterday. So how do these sale things works, right? So if Flipkart announces that there is going to be a sale today, right? What they do, in fact, is that they will expect some traffic, people to come in and, try to buy stuff because they have announced the sale and a lot of marketing has done, and people are definitely going to come. So that's not their problem. Their problem is they may not know what they will buy. Well, you can predict for sure. So deep learning, machine learning, everything we use, but you can predict up to certain extent, but you're not really sure what people are going to buy on the website. So what they do, one thing that they does, apart from all these things, is that they are going to look at, how do I say, the data in real time. For example, Flipkart will announce that there is going to be 40% sale on mobile phones. They will not say which mobile phone. Sometimes they say, but in most of the cases, they will say, okay, we're going to give you 40% sale offer on mobiles. Now, what happens? People rush to the website, and what they do is that they collect the data in real time. The kind of data, we call it as clickstream data. For example, where are you clicking? What are you searching in the website? So if I can figure out that in the last 20 minutes, most of the people are searching for Apple iPhone. As an example, I'm saying Apple iPhone 8 or something like that. I can put up offers and ads specifically on iPhone so that people will buy it more. I will know this only when I look at real-time data. So one thing that they do is this dynamic pricing and offers. So they do something called dynamic pricing and offers. Based on the user activity in the website, they have to adjust the offers, the pricing, the discount, everything. So the site is dynamically getting adjusted based on your user traffic. The second thing, there is a dynamic inventory management. For example, if lot and lot of people are ordering a particular item, you will run out of stock. So you need to manage your inventory. This has to happen in real time, right? So also the entire product inventory has to be managed in real time because end of the day, you need to sell everything, right? So depending on what users are searching for, what is their interest, you have to give them offers and make them buy. So that is an example of real-time analytics because even though you understand the users, what they might buy, might not buy, not everything can be 100% predicted, right? So using Spark as an example, what they did is that they built this real-time pipeline where they monitor user activity and try to figure out the best offers for each user. So that's one thing that we do in the e-commerce industry. The second example comes from banking. In banking, what happens is that this is very common, but there is something called credit card fraud detection. So, see, during festival seasons and all, people use their credit cards like crazy, right? Because you don't want to pay money, you may not have money, right? So you use your credit cards like anything, crazy, right? Now, how do you know whether a credit card swipe is a fraud or not? You don't know, right? Also, they want to segment the transactions, credit card fraud and segmentation. So what happens? You could have experienced this. If I swipe my credit card, let's say my limit is 1 lakh rupees, and if I swipe my credit card for like 70,000 rupees, I will get a call from customer care. They will ask like, did you really swipe your card, right? Because they suspect that it is a fraud transaction. Or if you say that yes, I did, then they will ask, do you want to convert it into EMIs, right? So how does this system work? So again, the requirement here is that I have to collect millions of transactions, say per minute, right? And I have to feed them into a machine learning algorithm. So multiple things we do. First, we do a basic level of check. For example, the location check. Say if you're swiping your card, the bank can understand the location. So we do a location mapping, basic location mapping, and then we do a limit check, and so many other things. And then we feed this data to a machine learning algorithm, which will predict whether it is a fraud or not. And then the actual call will go to the customer. So the challenge here is I'm looking at millions of transactions every minute. And for each one of them, I need to make a decision real time. How do I do it? Right? So that's a very common use case. Third is advertisements. So this is your real time ads. So you go to these websites and you see these ads. The ads are based on your cookies, right? The ads are based on your cookies, that the information they save, but there is a requirement for customization of ads as well. For example, if you're looking at a Redbus, right? So you're trying to, or let's say you're looking at Make My Trip, flight booking, flights. So if I look at Make My Trip flight bookings, right, the problem for the Make My Trip is that I might be searching a flight from Delhi to Mumbai. So when the ad has to be shown, it should have Delhi to Mumbai. They cannot show a generic ad, right? So this data has to be captured in real time, first of all. And then they need to make a decision whether the ad need to be shown or not. If yes, the ad has to be shown with this particular data. So if I'm searching from Delhi to Mumbai, I should see an ad of Delhi to Mumbai only. Then only I'll book my flight, right? If I see a very general ad of Make My Trip, probably I'm not interested, right? And also these customized ads that you see on many websites. So all of this has to do with real-time data analytics, right? So if you ask me, this itself is a huge field actually. Real-time data analytics itself is kind of like a very, very big area, right? And to look at a bit of history, initially we had somebody called Apache Storm. Apache Storm is probably one of the earliest, how do I say, earliest use cases for real-time data processing. And in my opinion, Storm is probably the most popular one as well. Not now, but at one point in time. Storm came long back actually. Okay, I think somewhere 2012 or 13. So in those days, there was absolutely no way to do real-time processing on big data, right? So Storm is an independent project. The problem with Storm is that you have to learn it, you have to install it and manage it separately. Storm has nothing to do with Hadoop or any of these things. So everything has to be. So if I have to implement real-time processing, I need to sit and learn Storm and then understand what it is, install it, integrate with Hadoop, and so on and so forth. Unfortunately, I have not worked on Storm. Okay, I know people who work, but Storm is a great, what you say, real-time processing engine, in my opinion. So Storm was one of the early real-time processing platforms we had, right? But the real deal here, what we are really talking about is this guy called Spark Streaming. So Spark has a module called Spark Streaming, right? And Spark Streaming is the module in Spark which can do real-time processing, right? And this is like crazy. Why this is crazy? Because if you look at the industry, there is also somebody called Apache Flink. There is somebody called Apache Flink. There is also somebody called Kafka Streams, which is getting a lot of traction these days. Kafka Streams, etc. So these are all different products which can do real-time processing, or probably I can say competition to Spark Streaming. Now, there is a difference between collecting the data in real time and processing the data in real time. So if you look at Kafka, the original Kafka is a data collection mechanism, or I can say a message queue. So what is Kafka? Kafka is a platform where you can collect the data in real time originally. But what they did, I think for the last 2 years, they developed something called Kafka Streams. Kafka Streams is basically analyzing the real-time data. So everybody is into analysis. Even if you go to Amazon, AWS, the cloud, Amazon has something called a kinesis or kinesis, whatever you call kinesis. So real-time analytics is a very hot thing in the industry now, and lot of companies are investing their money. I know only this. There can be plenty of other products in the real-time analysis market, right? But these itself are like competing for the #1 position. But among all of this, Spark streaming seems to have an edge, right? Why? So see, there are a couple of things which are really interesting about Spark streaming. So I'll probably take Spark streaming because that is our topic. Well, some of the other products can also do it, but what is so special about Spark streaming, right? When you talk about them, the first advantage is that, for example, it is completely fault tolerant. When I say fault tolerant, in most, how does it work? It works basically on the idea of, how do I say, Spark's fault tolerance only, right? But in most of the cases, it is highly scalable and fault tolerant, Spark streaming, right? But the real deal here is the integration with other libraries. Look at Storm, for example. So if you're working on Storm, I think now they support it, I'm not sure. But in the earlier days, what used to happen is that, okay, I built a real-time pipeline. No problem. I'm getting data in real time. I'm processing data in real time. Everything is working happy with Storm. So Storm's job is analyze the data in real time. For example, you are getting credit card data, credit card swipes you are getting, and Storm is processing this data. However, if I want to apply, let's say, a machine learning algorithm, if I want to develop and apply a machine learning algorithm, that is not directly possible with Storm. Storm is not designed to work on machine learning, at least the original Storm. So the problem for you is I have to write my machine learning algorithm separately, say using Python or something. Then I have to deploy it. Then I have to integrate that with Storm. So Storm naturally doesn't understand machine learning or doesn't work with machine learning. And if my algorithm changes or if I have to modify any of this whole integration process has to happen again. The advantage with Spark streaming is that since everything is under a single umbrella, RDDs, Spark SQL, Spark streaming, machine learning, it can seamlessly work. So if I want to write a machine learning algorithm, I can use Spark. Spark has a library called mllib for machine learning. In fact, Spark is the #1 product when it comes to distributed machine learning. As of now, when you look at the number of people who are using machine learning on big data, Spark is the #1 product, right? So I write my machine learning using Spark. I do real-time processing using Spark. Everything is inside the same thing. So there is no hassle of, and the data also can be interchanged. So I don't have to depend on a separate framework for machine learning, separate framework for streaming, etc. Everything works seamlessly, right? So I can even write SQL queries if I want, because Spark SQL also works very well. So the integration is the really upside of what you say Spark streaming, right? Which was not possible with Storm. I think now they do it. There is a product called Flink. Flink also does almost what Spark does, but it is not very popular in the market. Kafka streams, in my opinion, they do not support machine learning right now. Amazon Kinesis does not support directly. You have to do it separately. But Spark is probably the first framework which started supporting this. And the third advantage is you don't have to learn anything new. What do you mean by this? So if I'm using Apache Storm or Apache Flink, I have to learn their language, their API, how they work, how to write a program. When I'm using, Spark streaming is what, end of the day, it is nothing but a continuous flow of RDDs. So any program that I write in Spark streaming is nothing but transformations and actions. So you don't have to learn anything to write a Spark streaming program, honestly, right? So right away, a developer can start writing streaming applications. That is wonderful, Because otherwise, if you look at other projects, the hard part is learning how this works, right? So here, if you look at Spark streaming documentation, I will show you. It will have all the regular transformations and actions that you are familiar with in Spark. Now, I must also tell you a couple of things since we are in a training, right? Um, Probably I can go to the documentations to talk about it. If I go to spark.apache.org, let's say we pick 231, sorry, 231. If you give me a moment, just look at SQL one thing, okay? Yeah. So if I go back and look at, let's say, streaming documentation, here it says there are two things when it comes to Spark streaming. There is something called structured streaming, and there is something called Spark streaming. I should tell you about this because otherwise you will go and ask, hey, why didn't you talk about it? See, Spark streaming is the original API. It's called old API because it is the original API. So what we are going to discuss is Spark streaming, and this is the original API. And here what happens, what you do is that you create a stream of data, a real-time data, and under the hood, everything is RDD. So if I want to do analysis in real time, I need to write transformations and actions in Spark streaming. Structured streaming, what happens? Again, the same idea. You create a streaming program and data comes in real time, right? But under the hood, the data is treated as a data frame. So basically, you can write SQL on top of real-time data. That is called structured streaming. That is rather a new idea. So to be really honest with you, I have not worked on structured streaming a lot because structured streaming came almost a year or two back, right? There are people who are working on structured streaming, but I don't have much experience on working on structured streaming. So we have Spark streaming. The difference is that here I use RDD, here I use Spark SQL. And obviously, going forward, I think people might switch to structured streaming, right? Because data frames and SQL are the norm these days, right? So there are two ways to look at this. We are going to look at the Spark streaming API, the original Spark streaming API, right? And if you look at here, so there is a documentation for this, but if you look at somewhere, it will be written, yeah. If you look at transformations on D streams, see map, flat map, filter, repartition, union, count, reduce by key. So these are all the things which you already know from the RDD class. So there is nothing new on but when it comes to transformations on Spark streaming, right? And D stream is nothing but the API that we use. What is D stream? D stream is nothing but a continuous flow of RDDs. So your primary requirement in Spark SQL was to create something called a data frame. If you remember Spark SQL classes, what we were doing, the first step that we did is that we learned how to create a data frame from an RDD, from a Scala collection, etc. In Spark streaming, you have to create something called D stream. D stream represents a continuous flow of data, right? It represents a continuous flow of data from any source, real-time source, right? And then you write your programs on D stream, your transformations on D stream. So you need to create a D stream. Once you have the D stream, it starts working, and then you write your code on top of the real-time data. And all of this is by default in memory. So this happens in memory in the sense the data will flow in real time to the cluster. Your Spark cluster will keep the data in memory and do the analysis on the data in memory. And the output, you can decide what to do with the output. You can store it or you can display on the screen or anything like that. So the important point here is that we are not interested in the original data. For example, there are many use cases where you do real-time analysis on social media data. And I will show you an example, right? So what we will do, we will connect with Twitter and stream all the public tweets live, and then we will do some very basic analysis on these tweets, right? So what this means is that, let's say you are analyzing Twitter data. So I want to know which football player is trending. So this Lionel Messi, or I don't know, Cristiano Ronaldo. So based on the number of tweets and people talking about the football player, I want to know which football player is trending in Twitter. So what I did, imagine you started collecting all the tweets related to football. The point I'm trying to tell you is that you are not really interested in storing the tweet, right? In fact, the tweet is not really important at all. You are interested only in the output. So if I'm getting 1 million tweets about Messi, I get the output saying that Messi equal to 1 million and Messi is the #1 trending player. That is what I want to store. I don't want to store 1 million tweets. It's useless. There is no use for storing 1 million tweets because this real-time data is useful only at the time of its generation, right? Yesterday's tweet is no longer relevant today unless you want to do some really hardcore batch processing on that data. But usually that is not relevant. Yeah, sometimes we do it. Sometimes what we do is that we get this data, we store it as well so that we can analyze it in future. But when it comes to real-time analytics, more or less we depend on the output, right? Yeah, so you just want to see the stats and you want to just store it, and that's what we do. Now, there are some slides. Basically, what I explained is this slide so far. So I'm gonna go to the important part in the slide. So Spark streaming is used for processing real-time streaming of data. It is a useful addition to the core Spark API. Spark streaming enables high throughput and fault tolerant stream processing. We have seen that. Yeah, so this is probably something that you can relate to. This is how a typical stream processing workflow will look like. So what you see here is that you will have sources. The source of data can be, I don't know, if you are collecting chat messages in real time, it can be a chat server, it can be social media, it can be credit card swipes, it can be data coming from your mobile phones, it can be data coming from sensors, it can be anything. Any system which generates data in real time can be a source. Now there is a intermediate part called data ingestion. So data ingest, the second part. See what happens, you might need an efficient mechanism to collect the data. That's what I'm saying. So you have two approaches here. One approach is that Spark streaming can directly get the data from the source. That will work if the amount of data that you're getting is limited. For example, imagine you are looking at credit card swipes on a typical, how do I say, non-seasonal day. Let's say you are looking on a Wednesday, right? So maybe you're getting an average of, just an example, okay, 100 swipes in a minute. Imagine you are getting 100 swipes in a minute. So you see, if that is your requirement, all I have is like 100 swipes in a minute, and I want to collect it and analyze it. Probably Spark can directly connect with the system where the swipes are landing and process it. But if I'm getting like 1 million swipes in a minute, directly collecting this data using Spark may not be a good idea, because end of the day, Spark is not a data ingestion system. So that is where these guys called Kafka, Flume, all can help you. Kafka, Flume are data ingestion, systems. What they do, they are not same, and also you cannot compare them. So many people do a comparison between Kafka and Flume. In my opinion, you should not really do a comparison between Kafka and Flume because they don't have anything in common unless they collect the data. That's the only point. Kafka is like a distributed message queue. Flume is a point-to-point collection agent. What Flume does, it takes data from one point to another point to point, right? For example, I have a web server which is continuously generating log files. I want to collect it. I can use Flume. One side of Flume will connect with web server. The other side will connect with wherever you want to dump the data. That's it. Point-to-point data. Kafka, on the other hand, what it does, it first of all, it is like a publish-subscribe system. People can send data to Kafka, and it will store it. And then anybody who want can subscribe and get the data from Kafka. So Kafka can store terabytes and petabytes of data if you want, temporarily. So the idea behind Kafka is that multiple people can send the data and multiple people can receive the data, and all of this can be stored in a distributed cluster. Kafka typically you install in a cluster. Okay, so depending on your use case, you might use Flume or you might use Kafka, depending on what. Kafka is like a publish, subscribe kind of like a platform. But let us assume that you have a data ingestion platform that ingests the data. Then Spark Streaming gets the data from any of these guys. It processes the data in real time, right? And the output can be stored wherever you want. You can store it in Hadoop, you can store it in Cassandra, or anywhere you want. Finally, somebody like Tableau can connect with these systems and visualize the data. So if, let's suppose, you have Tableau, you have created a Tableau dashboard, it can connect with your Cassandra or Hadoop or anything and visualize the data. That's a typical workflow that I'm talking about, right? Ashwin was saying basically pooling the low data in one place and analyze it. Yeah, yes, correct, right? So here the point is data ingestion is basically, why do you want to do data ingestion is to avoid missing data, because Spark streaming, even though it is 100% fault tolerant, if it crashes for some reason and restart the processing, you may lose some part of the data. If you are using an ingestion tool, something like Kafka, it never fails. So whatever data you're getting in real time will be in Kafka. Even the processing engine loses connectivity, crashes, or anything, it can get it from this part actually. So in Spark streaming, we create an object called a streaming context. And this is important, right? So whenever you write a Spark streaming program, Spark streaming application, you create something called streaming context object. Why do you have to create this object is because this is the object which helps you to set the configuration for streaming. The configuration for streaming may be different than your traditional Spark programs. The most important point in Spark streaming is that people often call it as micro batch architecture. That can be a specialty, that can be a drawback. What do you mean by micro batch architecture? See, what Spark streaming actually does is that when you create a stream, real-time stream, okay, let's suppose you're processing credit card swipes, right? So you have already created a D stream and you're collecting the data. Now you want to process it in real time. When you say, I want to process it in real time, how do you want to process it in real time? Many people think that each transaction will be processed independently. No, that does not work. So ideally, when you say real-time processing, let us say if you are talking about credit card swipes, ideally, real-time processing means even if you are getting 1 million swipes, each swipe has to be processed the moment it is arrived in the system. But in case of Spark streaming, we use a concept called batch interval. We use a technique called batch interval. So basically what you do, you have to set something called batch interval. Batch interval is basically a time. It can be hours, minutes, second, microsecond, anything. So let's suppose the batch interval is 1 second. So what will happen every 1 second, how much data that you have collected, it will process. So in a way, it is batch processing in real time. That is why you call it as micro batch architecture. So if I set my batch interval as 1 second, what is going to happen in Spark streaming is that every 1 second, the last 1 second, how much data it has collected, it will process.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and DataFrame? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now, let's continue with the session.
So it may contain 3 credit card swipes or 300 credit card swipes. But it is all time-based. It is not transaction-based. That is the difference. And the batch interval can be increased or decreased, which is a good thing. For example, if I'm looking at my e-commerce example, right? I want to know how many people are searching for Apple iPhone on Flipkart. I don't want to know this every second. It is useless for me. I want to know this every half an hour. So there my batch interval is half an hour or probably 15 minutes. So I want to adjust my ads based on what people are searching on my website. So I don't want to process each user what he is doing every microsecond. That is useless for me. Basically, I just want to process the user activity every half an hour or every 15 minutes. In that example, batch interval is very much useful because my batch interval can be 15 minutes. So Spark streaming will wait for 15 minutes. Every 15 minutes, it will apply your analysis for the last 15 minutes data. So batch interval is what we need to use in case of Spark streaming. That is why it is called micro batch architecture. So if you are looking at real time processing, the batch interval will be very slow, 1 microsecond, etc. But on the other case, again, you want to know which football player is trending on Twitter. I don't want to know this every second, right? I want to know every 10 minutes who is trending or every 1 hour who is trending. So you collect the data for 1 hour, then process it. So it looks like batch processing, but it is not. It's continuously happening. That's what I'm saying. So streaming context, yeah. So these things like setting the batch interval all have to be done by on this object called a streaming context object. So this is what I was talking about. The data stream is divided into batches of X milliseconds. In this example, milliseconds, it can be seconds, it can be minutes or anything. So processing Spark data stream. Imagine your batch interval is 1 second. It will first process data from 0 second to 1 second, then 1 second to 2 second, then 2 second to 3 second. So every 1 second, last 1 second data will be processed. That is how you control this. Okay. No, all streaming tools do not work on a micro batching model. In my opinion, only Spark works like this. If you look at Storm, Storm doesn't work on micro batching. Storm has real-time processing. It is event-based. Each transaction, each event can be processed individually. Is it good? I don't know, honestly. It's not good or bad. That is how they work. Okay, so Storm is more event-driven. Spark is more time-driven. So here time is what we use to chop the data into small parts. Their event is what you use to chop the data, right? So both have a different architecture. Even Flink, I think, is based on kind of like events only, I guess. So this is now this is what you need to understand: streaming source and destinations. Let me see if I have an example of this. Yeah. So when you want to create a real-time streaming program, the first thing that you need to figure out is from where am I getting the data? That is the source. Now, there are multiple types of sources supported. There is something called file-based source, HDFS, network-based source, TCP socket. I will show you an example of these two today, right? Then there are other sources, we call them advanced sources, like Twitter, Kafka, Flume, so on and so forth, Kinesis. So Spark streaming can process the data which can be given by Kafka, Flume, Twitter, Kinesis, all these guys, and much more. So if you look at the number of sources, there are many. Right. So they classify that into basic sources and advanced sources. Basic sources are the one I have highlighted now. File-based source HDFS, network-based source TCP socket. They are called basic sources. The remaining ones, Kafka, Flume, they are all called advanced sources. I will demonstrate. And you see in production, what happens is that the data collection will normally be not handled by the developer. It will be handled by the administrator. Because if you're a developer, chances are very low that you will have permissions and authorization to modify stuff and change the data streams and all. So if I'm a developer working on Spark streaming, I'm probably interested in writing the program. Then I will go to the administrator and say that, okay, this is a Spark streaming program. It is supposed to get data from Kinesis. So he will figure out how to get the data from Kinesis. What kind of a plugin or connector need to be used for Kinesis and so on and so forth, right? And the major challenge that we have is that once you write a Spark streaming program and deploy it in production, it runs 24/7, unlike batch processing. Batch processing will stop once you get the output. We have customers who are running Spark streaming programs for the last 2 years. They have submitted the program in 2017. It is running today without stopping. And that is how the requirement is, because you cannot stop it. It is real time, right? So as long as the data is coming, it has to run. So the challenge here is for resources. And a lot of people ask that question to me. How do you manage resources? Because in batch processing, I can manage resources. In real-time processing, when I look at it, Spark requires this executors and RAM and processor core. What will happen if you start getting data which you cannot handle, right? What will happen if resources are not enough for your processing? So there are many approaches to this. There is one approach where we fix the number of resources and we deal with the input data, amount of input data. We make sure that the input data is within a threshold. It does not cross, right? Because otherwise the processing will become slow and it is no longer called real-time processing. But there is another approach where in Spark, I can do something called dynamic resource allocation. So in Spark, there is a technique called dynamic resource allocation. Dynamic resource allocation. What is this? In dynamic resource allocation, I can submit a program to Spark and tell Spark that, okay, I want to start with 2 executors and I can go up to 100 executors. You adjust accordingly and Spark will do it. So this is quite useful in kind of like streaming applications and all. When it comes to streaming, the data might change, right? So you have to adjust the resources automatically. So I can say probably I want to make use of dynamic resource allocation, and accordingly, Spark will automatically adjust the what you say executors in your cluster. And we do this sometimes. It is good that we have something like this. So you need to set up something called a resource allocation policy and so on and so forth. I can give you something to read about this. Databricks, Spark, Dynamic. So there is a Databricks page. It's a video basically. This is an old video, 2016, but the concept is same. So just go through this if you want to know how dynamic resource allocation is working under the hood, right? There is a video for that, right? Well, it's basically talks about how do you scale your executors, how do you scale up and scale down your executors based on the data that you have, right?
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
What is Spark RDD? So now that we know what the basic features of Apache Spark and what Apache Spark is, we can now move on to the Apache Spark RDD. So RDD stands for Resilient Distributed Datasets. So when we start up Spark, in Spark, basically it is the fundamental building block of Apache Spark framework, the fundamental data structure of the Apache Spark framework. So the RDDs are immutable distributed collection of objects. So they are immutable in nature, and each data set in an RDD is divided into logical partitions. So because we are using this on a distributed file system, the data sets that are present inside an RDD are divided into the logical partitions based on the division that is required on the different nodes of the cluster. And RDDs can contain any type of Python, Java, Scala objects. So basically RDDs are very easy to integrate with Python, Java, Scala objects, or R for that matter. So those are the benefits and what basically the general idea of a resilient distributed data set is. So now we will move on to the workflow of the RDD. So here we have on the left hand side, as you can see, RDD1 and RDD2. So they are combined and there is a distributed acyclic graph. So basically we can see that there is a DAG scheduler, which means the combinations are then further combined and then the combinations are further processed. There is a task set. The task set basically means that there's a cluster manager and there's a task scheduler as well. So the tasks are scheduled, jobs are scheduled in the order of the creation of the jobs, or in the order of basically the resources that are available. So these tasks are scheduled, and then basically when the scheduling reaches the point where the tasks have to be executed, the tasks are executed in the executor where the threads and block manager are present. So the threads basically means the availability of the slots where the tasks would be executed, and the block manager basically means the combination on all of the nodes that are basically present within your cluster where the data blocks are present, and the further combination, the further processing of the data occurs. So now that we know what the RDD workflow is, we will now move on to the type of RDDs that we have. So there are different type of RDDs. As per Spark source code, RDD is an abstract class having few methods. So there are not a lot of methods that are present in the RDD, but there are a lot of transformations that are present in the RDD, which is very important when we are processing big data, because we need to transform data a lot. So let us look at the different types of RDDs. So firstly, we have our parallel collection RDD, where we can see that we've created a value A. This is a Scala shell, by the way. We're using the SC, which is our Spark context variable dot parallelize, and there are two elements to it. So basically, the partitions that are present inside of this value, inside of this RDD that we've created, are two partitions. So when we run a.partitions.size, we basically get 2. So that is essentially what it means. And then we have the next one is shuffled RDD. So a shuffled RDD is a RDD of key value pairs that represents the shuffle step. So we had a shuffle step when we use big data analytics, where all of the keys that are of the same sort are sorted when we are creating our final output. So basically a shuffled RDD implies that all of the values that are present inside the RDD are sorted by the key. So when we run dot sort by key on any RDD, for instance here in this particular example, we're running it on a variable M. They are basically sorted in order. We can see we have our particular sequence, one which is mapped to a particular value, and then we have 5 which is mapped to a particular value, so on and so forth. So basically what will happen is when we sort this particular data, it will basically sort it in the order of the ascending order of the keys that are present within the data set. And then we have our paired RDD. So the paired RDD basically means that these data sets, these RDD are key value pairs, which are particularly helpful when we need to perform similar operations on keys on each key. So for instance, here we have something like dot count by key. So what does that mean? So basically what we're doing here is we're running an operation where wherever there is a key, it is basically being counted and how many, in what quantity does that particular key exist. So in here we can see we have 3, 7, 5, 4 and 2 as keys, and they have particular values that are mapped to those keys. So wherever there are values which are mapped to those keys, we see a 1. We see a mapped value which is 1 that is mapped to those keys when we run our dot count by key. But in the case of 2, we can see that there is no value which is mapped to that particular key. So 2 exists on its own without any mapped value to it. So in our dot count by key, we don't see 2. So that is because it has 0 values mapped to it. So that basically means that when we run the count by key operation, we get all of the pairs that are present inside of our RDD. When there is no pair and there is no count that is to be displayed for that particular supposedly non-existent pair, then it shows us the null value, which means that the value will not be showed in our final output when we run the count by key. And then we have our Hadoop RDD. So if we have our text file, if we have a Hadoop file or a sequence file for that matter, and we create an RDD using the Spark context, we can create an RDD out of that. So that would basically create a string value or a numeric value depending on the data type that is present inside of all of those files. We basically create an RDD out of the files that are already present or pre-existing in our disk. So we can basically copy that into our memory. And then we move on to the RDD operations. So basically we have certain operations that we can run on these RDDs. There are not a lot of functions, but there are certainly operations because we need to transfer this data. As you can see in the diagram, we can run a particular transformation on an RDD, and the action will occur after the transformation is run on it, and the value will be generated after that. So the thing about RDDs are that they are immutable because they are in memory. So they are present inside of the memory and they are not changed when we run a transformation on them. So basically what happens is whenever we run a transformation on an RDD, it returns a new RDD. So it is important for us to create a new RDD if we want to create a new RDD variable. Essentially, if we want to store the new RDD that we created, inside that variable we can store the new RDD. If we try to use the same variable again in order to store the new RDD, it will give us an error because RDDs are immutable in nature. So transformations are lazy operations on RDD. So lazy means that they are in-memory operations because we are not essentially altering the current RDD. Basically, we can set all of these steps up before we actually run our RDD transformation. So Spark knows what to do with that data and how to do it. So then we have certain transformations, certain examples of transformations, which we're going to be discussing some of in our hands-on tutorial section that we have later on. So map, flat map, filter, map partition. So if you're coming from a data analytics or data science background, some of these terms might be familiar to you, like union, intersection, distinct, group by, key by. Even from an SQL background, you might be sort of familiar to this. So in Spark, we can run these same operations on RDDs as well. Now that we know the basic implementation and introduction of RDDs and know that RDDs work in memory in a certain way and they execute when we actually call upon operations that call for their execution and not during the statements that we make which set up the execution. Now we can understand how RDD works by a tutorial. So firstly, let us start our Spark shell. You type Spark-shell, enter. If you have your Spark installed, it will take some time to start up, and then we will see that the Spark has started with the sc context variable. So we can simply now create a list with a certain amount of partitioning, call this val x equals sc.parallelize. So the parallelize option gives us a way to create as many partitions as we want for our particular data that we are creating. In our case, we are creating a list with certain string value. So the first will call Spark RDD example, any values that you would want. This is just to show you guys how simple it is. If you are coming from an SQL or data science background, to get get started with Spark, sample, example, again, then close this up. We can use the number of partitionings that I would want for this is, for instance, say 3, and close this up. And then when I press enter, our value X, our list, our RDD would be created. So as we can see, an RDD has been created of a string data type, and we can now go ahead and run new operations on this as well. So for instance, say I can run a map operation on this. So I can map all of these string values to a certain integer value. So say I want to create a new RDD, I'll call this Y, and I want to take X, and as I discussed before, create a new RDD out of X, because there is no way that we can actually transform X. We always need to create a new RDD and store it inside of a new RDD. So x.map, and that would mean that for every variable that is present inside this X, we can map a certain amount of a certain implementation for it. So say I want to map every variable that is present inside of the X RDD with 1. So I can simply type X, 1 and close this up. And when I press enter, all of the values that are present inside of X are now mapped with 1. So if we just see how this looks, so if we type in y.select to view our new RDD and press enter, so we can see all of the string values have been mapped to 1. So we have, we can call this a key value, and this is a value. This is a key, and this is a value, and they have been mapped together. So the mapping part of our operation, if we were doing a map reduce operation, has been done. So next that I would like to discuss is a filter operation. So this is like a or just a flat map operation. So what does a flat map operation do? So the difference between a map and flat map is the flat map converts even a multi-dimensional array into a single dimensional array, right? So let's see how does that work. So say that if we were running an operation such as this, sc.parallelize list, and create any list that you would want. I would create 1, 2, 3, a new an integer list with the values 1, 2, 3. And when I perform a flat map on this, simply type flat map, syntax sensitive, and the values that are present, the variables that are present inside this flat map, I would map them onto another list, a sub list, which would be x, x, and then perform a collect on this, so we can see what it looks like when I press enter. So as we can see, even though I'm mapping each of the values, that is 1, 2, and 3, to a list which should contain the values repeated thrice, it is not actually doing that. What it is doing is essentially creating a single dimensional array where the values that are there are occurring only three times. So that basically means that whenever we run a flat map operation on things, it basically doesn't create a nested array within that array. It creates a single dimensional array. So if we were running this for a simple map operation, if we just remove the flat from here and convert this into map, and then we press enter, so that would contain a sub list. So let's see how does that. So now we can see that for every x, when we are mapping it with a list, so what is happening is essentially all of the values that are present inside this list are being replaced by thrice repetitions of those values. That means 3 sub lists that are present within those particular value areas. So this is what the map does, and this is what the flat map does. So I hope that difference is clear. So now we can move on to certain SQL operations. So we have this where option in SQL, right? So simply we have a similar implementation in Spark as well. We call it filter. So say if we create a list, we can call this list, let's create a list from here, and it's a numeric list, so something like this, like Z. We call it numbers because we're going to be storing numbers inside of this, and within this list we can put in values such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then close up this list and create an RDD which we will call numbers. So say that we want to filter out only the even values out of this particular RDD that we have created. We can simply create another RDD for this. We call it evens, and we'll put in something like numbers.filter. So that would filter out the RDD RDD in the criteria that we would now write. So we will write underscore %2 equal 0. So once we do that and type in collect, it would basically filter out all of the values which has the modulus with 2 equivalent to 0. So whenever we are typing an underscore, that would include all of the values that are present inside of the RDD, and the modulus with 0 should be equal to 0. Modulus with 2 should be equal to 0. That is the criteria for even. If you've done programming before, you would understand that. And when we do collect, it would essentially show us all of the even values that are present inside of this RDD. So this could be any criteria that we would want. So if we could simply type in something like events, odds, so that would create something like, and we type in not over here, so that would give us all of the odd values as well. So as we can see, 1, 3, 5, 7, and 9. So all of the odd values that are present inside of that RDD are there as well. Type it like union. First we have to perform a union, and then after we perform the union, then after that we will type in distinct over here, and that is how it will happen. So first we need the full entire RDD that contains both of the values, and then we need to form the distinct. So that would give us the non-common values that are present within both of these RDDs. So when we press enter, so we'll get all of the values that are not common within both of these RDDs, between both of these RDDs. Then obviously we can run something such as sort by. So how does sort by work? So now that we've created an RDD, we can simply type in something like this. We can use parallel for this, parallel dot sort by, and then give a criteria for the sorting. So something like variable C, true. Select. When we press enter, we can see that the original array that we had for this for the parallel was 1 to 10, and here we also have 1 to 10 as well. Then we can use something like zip. So zip basically combines two particular RDDs in a different manner as well. So how does zip work? Say for instance, when we were using union, so that combined all of the elements that are present within both of the RDDs. What zip does is something in a quite different manner. So how does this work? So we'll see that. Firstly, let's create one RDD. We'll call it zip1, and create a list within it like 1, 2, 3, 4, 5, 6, 7, and 9, 10, and press 9. We will create another RDD with list 2, and create some other elements in this like 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. When we press enter, we'll create another RDD. So we'll create zip final and make it equal to zip1 zip, which is our RDD transformation statement, zip 2. So when we do that, it will create our zip final, which is the zip version of both of these RDDs. We simply type in zip final.collect to see our output. So we can see that the values that are present within both of those RDDs are mapped to each other in such a way. Like 1 is mapped, like here we can see 1 and 11, they are both mapped together, and 2 and 12, they are both mapped together. So basically in the sequence of their occurrence, the RDD values are mapped to each other. So that is what we can do with zip. So these are some of the few examples, some of the few things that you can do with Apache Spark. So you might be thinking, what is so special about this? Why can't I do this with simple Python? You can certainly do it with Python, but the thing about Python is Python on its own cannot process large amounts of data. So as much as I am doing this right now with a very small amount of data, like numeric data set that we have over here, Apache Spark's special quality is not in the methodologies that it provides. It is in the overall implementation and the background that it provides, like the in-memory processing and processing over a distributed file system. So all of these things, processing over a Hadoop cluster. So all of these advantages are done in the abstract form by Spark. So you don't need to worry about the logic of it all. You simply need to focus on the big data analytics aspect of things and not on the configuration, not on the distributed file system and any other aspect. So that is the main advantage of Apache Spark. So if you're interested in this, if you like what I showed you right now, you can simply try this on your own. Look at tutorials online, look at how to install Apache Spark. You can find it on our own website as well. You can basically will guide you through the learning path of Apache Spark in just a moment right now.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD, B. DataFrame, C. Dataset, D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
What are data frames in Spark? So now that we know what data sets are, data frames are essentially a data set organized into named columns. So data sets are essentially arrays that are unstructured in a way, and when you convert those arrays into a actual table, an SQL table, that table is called a data frame. So it is conceptually equivalent to a table in a relational database management system, for instance, a MySQL or an Oracle database. And it is also sort of similar with the data frames that we create in R and Python. So if you're coming from a data science background, you might be familiar with the data frames that are possible in R and Python as well. But Spark is obviously built for big data analytics, and that is why it is easier to basically analyze big data sets with the use of Spark. So as we can see in the diagram, the data set object, the JVM object, the dataset object was once transformed using the map, filter, or flat map function, whatever it was, into furthermore JVM objects. And then by using the simple 2df function, which means the two data frame function, we converted them into a Spark data frame. So this Spark data frame has named columns and is essentially a very well structured format of data. So we can perform queries on this, SQL queries on this, and basically overall treat it as a structured data set. So the APIs available for Java, Scala, Python, and R. So the data frame API is available for Java, Scala, Python, and R. So if you're even from a Python or R background, you can still use Spark data frames very easily. So now we move on to the data frame tutorial. So I'm going to be using my Linux virtual machine to actually perform this. So let us begin. So currently we are inside our virtual machine, and we're going to be performing some analytics on a text file that I have created. So the text file is called ytlib. If I just open it up, the contents, we look at the contents of this text file. So these are this is the content that is present. So it says, hello from Intellipaat. Today we are going to be discussing Spark data frames. Hello from Intellipaat. So this is the content of the text file, and we're going to be performing some analytics on this. So the first thing that we're going to do is open up our terminal. So I'm going to just zoom this up so you guys can see clearly. So firstly, we're going to be starting our Spark shell. So type in Spark -shell for that. So that will start our Spark shell session. Yeah, so we have created our Spark shell. So right now, the advantage of Linux is it's pretty easy to install Apache Spark because we don't need a multi-cluster system to actually use Spark, and it's a preferred environment because if we are going to do this on Windows, then we'll have to virtualize the concept of a cluster, and it involves a lot of setup procedure. So it's always better if you can just get a virtual machine and then start to install Apache Spark. And then we can begin with our question. So firstly, I'm going to just create a variable to store our text file inside. So I'll call this RD, and I'm going to equate it to sc dot text file, because we're going to be analyzing a text file. So we need to import a text file with our Spark context, and our Spark context variable is sc. And then within our brackets, we're going to be specifying the parameter or the address where our text file is. So just open up double quotes and type in the address. So in my case, it's home training and ytlive.txt and then close. So I'm just going to verify whether it's that before I actually execute that. It's called ytlive.txt. Absolutely, it's correct. So now I'm going to begin. And then after that, just simply press enter, and it will create an RDD out of that text file. So we're going to use this RDD object and then essentially create our word count program first. So simply create another RDD. We'll call this counts and wait it to rd.flatmap. As we were discussing earlier, we can further transform this RDD line. So line is a variable. You can use any variable that you want, but I'm using line to indicate all of the lines that are present inside of my RDD object that contains my text file as a string, and line dot split, and I'll split this line on a particular regular expression. So this regular expression in my case would be double backslash w plus. So what does this mean? So this expression essentially implies that all of the special characters and numeric values present within our text file will not be included in the final data frame that we will create. So it will only give us the pure words, because we are going to be performing a word count, and then we are going to convert that word count RDD, the count that we receive, into a data frame, a structured data set. So that is why we're using a double backslash W plus instead of an actual space as our delimiter. So once we are done with that, dot map word, and word is another variable that I've created to indicate words as opposed to lines, and then every word I'll map it to 1. So every word, whenever it occurs, will have the count 1. And then I'll close this up, then type it reduce by key. So map reduce. I'm going to reduce all of these words mapped to 1. Whenever they occur, I'll add all of their values, which is 1. And then given the parameter that I want for this, which is plus sign, because I want to add all of the key values. And then press enter. So that creates another RDD, which, as we can see, contains a string element and an integer element. So the string element is the word, and the integer element is the count associated to that word. All right. So now we will actually create a data frame with the simple 2df function as we discussed. So we'll call this variable df, and we'll convert counts to df, right? Because we need to convert this RDD, this object, this JVM object into a data frame, and press enter. So the 2df successfully converts our RDD into a data frame. So on one column, we will have all of our words. On another column, we will have all of our counts. So we've created it successfully, and now we will now perform some operations on this. So the first thing that we can do is change the column names. So currently, we have _1 and _2 as our column names. If I simply type in df dot show and press enter, then we'll get our table that we have. So As we can see, the column names are _1 and _2, but we need to change these column names into something else. So for that, simply type in another, we're going to create another data frame. We'll call this df2, because you cannot actually change something that is already present. You cannot change an existing data frame. You cannot transform it. You'll always have to create new data frames or new objects, because Spark functions in memory. So whenever you're doing something new, you will create a new copy of that inside of the memory. All right. Okay. So df dot, the new data frame would be equivalent to df dot 2df, because we're going to be converting this into a data frame again. And the sequence of the column names would be word, count, because this is the sequence that I want my column names in. So I'm creating a sequence for that. And then I'm going to replace this, replace the existing column names, which is _*, with this new sequence of word and count. So how does that work? It basically means that _* represents both _1 and _2. The asterisk is replaceable with 1 or 2. That is what it means. If you've ever actually dealt with the Linux file system, you will understand that concept. So the word will replace the first, which is our _1, and the count will replace our second, which is our _2, and we will have new column names in our new data frame that we are creating, and we'll press enter after that. So we've successfully created two new column names in our new data frame. So if I simply type in df2 dot show and press enter, so as we can see, the column names are different in this. The first column name is word and the second column name is count, right? So let us do some transformations, or let us do some querying on the data frame that we've created. Now that we've successfully converted an unstructured data set into a structured data set, which is this word and count, proper SQL table, right? So now we can perform some queries on it and see how that goes. So as if you remember, in SQL, we have something called order by. So if I simply type in df2 order by, and if you want something like ascending order, right? If you want all of these counts in ascending order, we can simply use ASC for that. And given the column name count, dot show, and given like we want the first 5 counts, so do that and press enter. So we can see it has been arranged in ascending order. So if we just see this in ascending order, we have a lot of ones, so that will arrange automatically. And that is how we're getting a result. The first 5 results with 1 is what we are essentially getting. And if we want to ascend it, arrange it in descending order, we can simply type in BESC and count, and that would arrange it in descending order as well. So as we can see, the counts have been arranged in descending order too. Data frames also provide us with the filter function, so we can use that as well. So to filter out particular column attributes, if you simply type in df2.filter and given a criteria inside of double quotes, so I'll say count has to be greater than 1. So this is my criteria for the filter. So that's the query that I send in the function's parameters, count greater than 0. So that would go into the SQL context for this data frame, and type in dot collect and bracket open, bracket close, press enter. So that would essentially give us all of the elements present within our data frame that are above the count of 2. So we can also do it this way. If we want to simply see it as a data frame, remove the collect and type in show and press enter. So that would show it as a data frame. So this was showing it as an actual SQL row, but here it is showing it as a data frame itself. So you can use collect and show alternatively, depending on the use case that you may have. If you want to send data, then definitely use collect. If you want to display data, then use show. All right. So these were some of the functions that you can use with data frames. There are obviously a lot of functions that are possible because it essentially gives you the option to treat big data as an actual RDBMS table.
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Let us now get on to how to access data files. So I'll be showing you a brief hands-on on how to access the data files, and then we'll eventually move on to querying the data files. So accessing a data file is actually quite simple. Simply create a document first, right? So you can do this with the command line as well, but I'm doing it with some visual interface just to tell you guys how it actually works. So let's call this example.txt, right? So once you've created that, you can simply open it up and type anything you would like. So in our case, let's just type hello from Intellipaat. So this is just basically a data file, right? This is unstructured data in a way. There's no order to it. It's just a basic sentence. So if you want to convert this into a Spark JVM object, you'll simply save this first, right? Close this up. So this is also the present working directory that we have. So here is the file. Simply open up a terminal. So this is a terminal. I'll just expand the size for you guys so you can see. Yeah. So there. The first thing that we would do is obviously start the Spark shell, right? So the Spark shell by default starts in Scala. So it is a Scala shell with the Spark libraries already imported. So it takes a bit of time to start up, but it starts up. Yeah. So the Spark session is available as Spark, and the Spark context is available as SC. So this is a variable that we would be using to invoke the Spark context, right? So the thing that you would do is create a variable. I'll call this RDD, right? And equate it to the sc.text file. And given the location for where you want to take your source file from. So in our case, it would be from the present working directory, which is home training, and the file name, which is example.txt. Given the double quotes again, and close it up and press enter. So that would create the RDD out of that particular text file. So that is how simple it is to basically take a raw text file or a raw data file and convert it into a Spark RDD. So now we have reached the querying part. So let us see the exact procedure that Apache Spark follows for this data file querying. So as we can see, the way we achieve data querying is by converting the raw data that we have. In other words, the data files that we were referring to earlier, we basically convert them to data frames, and then we run normal SQL queries on them. So the definition of a data frame is it is a data set organized into named columns. It is conceptually equivalent to a table in a relational database or a data frame in R Python, but with richer optimizations under the hood. So to explain that in brief, it basically means that Spark data frames are equivalent to SQL tables, right? The relational database tables, or you could basically equate them to data frames that you would normally create in R and Python with vanilla R and Python, mind you. So it is basically equivalent to that. But the richer optimizations here implies that it is optimized for cluster computing. These are not normal data frames that are present within one system. These data frames could be present throughout multiples of systems on multiples of nodes in a cluster. So, and you wouldn't even notice the difference. You are just seeing it from one point of view where you see the entire data frame in one page, right? So that is the difference between a normal data frame and a say R/Python data frame, right? So the procedure here, as we can see, raw data, which could be semi-structured, unstructured, or even structured at times data, it's first converted into a Spark JVM object, right? So there are essentially two types of Spark JVM objects. Spark obviously uses JVM objects because it is an object-based framework. So one of them are RDDs, and the other is data sets. So you can basically convert them into JVM objects, the data that you have. So these could be arrays and whatnot, right? So once you have these arrays based out of the raw data that you've generated earlier on, you can convert these arrays into named columns, and those named columns are then called Spark data frames, which is our target anyway, right? So once you've converted them into Spark data frames, which are SQL-like tables, naturally you should be able to run SQL queries on it. And Spark actually allows you to do that because Spark provides the SQL context, which means you can pass string values which are equivalent to SQL queries that you would normally pass in, say, MySQL, and then basically analyze the Spark data frame that you have like an SQL table, and then get your query results as is. So that is how much Apache Spark simplifies analyzing big data. It brings it down so that a normal person who has experience in relational database management systems can use Apache Spark very conveniently without having to learn a lot of new things, right? So these are one of the advantages of Apache Spark, the accessibility that it provides, right? So as we can see on the bottom, Spark SQL context is created to run string-based SQL-like queries on Spark data frames. So as we discussed earlier. So now let us perform some SQL queries using the SQL context that Apache Spark provides on a freshly created data frame. So let us begin. So now let us take an example at a real life data set. So we'll be looking at a comma separated file, a comma separated value file, a .csv file. So this is yellow.csv. So what does yellow.csv have? So in order to give you a brief introduction to the dataset, it's basically a taxi dataset, like a taxi trip dataset. So you have your pickup date times and your drop off times and the total duration of the trip and the total distance of the trip, where the passenger was picked up and where the passenger was dropped off. So all of these things basically, and the distance between all of the trips and the amount, the fare and everything. So you can think about this as a taxi data that has been generated for the well-known taxi apps that you may be using on a regular basis. Well, not these days because of the virus, but in other ways. So Ola and Uber sorts. So this is basically the data that they're generating on a day-to-day basis. So if you just scroll down, we can see that this somewhat qualifies for a big data use case, right? And we're going to be actually running some queries on this data set. So firstly, this is in a semi-structured format, a CSV file. We are going to be converting this into a data frame before actually performing queries on it, right? So let us just quickly minimize this, or you can just close this off as well. Works the same. And open up our terminal, right? So let us continue from where we left off. So open up the terminal and expand this, right? So firstly, we are going to be actually importing our taxi dataset, which is the yellow.csv. Right? So let's create a data frame out of that. So we'll call this data frame df and simply type in Spark, which is the Spark variable that has been created, the session variable, dot read, and that then will give a simple dot format and specify the format of the file. In our case, it's a CSV file. Type in CSV for that. Close that up. Now we can give certain options to this. So we'll firstly give that we actually want the header. So the header is the first row that is present in each CSV file. So we want the header to be there. So we will simply give an header as true. We'll give some other options as well. We want this to be treated as a schema, so we'll do that as well. So this is a simple option for that. And for schema, we'll give this the Boolean value of true. Right, and then simply type in another option. You can keep on typing options, as many options that you would like. So you can, once you would actually start to understand Spark, you'll understand how many options there actually are. And given a mode for memory management purposes, so I'll give this a fail fast mode. And then simply type in the location of the file. So type in .load and given the location of the file. So in our case, home training yellow.csv, and close this up. And once you do that, it will automatically create a data frame out of that CSV file using the comma separated value functionality, and press enter. So it takes some time to load it all up. So, but once it loads it up, there's no delay and latency after that, because it is essentially loading it up inside of the RAM, right? So let us now continue with this. Firstly, we'll actually not call this the DF. We'll create a temporary view out of this DF so we can refer to it in the SQL context that we would invoke later on. So we would be renaming this table essentially and not calling it DF. This is an optional step, but it's for better readability of code. So it's always recommended. So create or replace temp view. And you can call this anything. In my case, I'll call this taxi data, and then close it up. Press enter, and it will create the new view, right? So after, we are basically referring to it as taxi data from now on whenever we use the SQL context on this particular data frame, right? So say now we can run some queries on it. So let us think of a query. Say we want to find out the total number of trips that have been taken throughout the data set, right? Simple. Simply invoke the Spark session variable, type in .sql. So we are now invoking the SQL context as well. And it's simple as anything. You can simply start a string value or double quotes and type in what you would normally type in MySQL, right? So how would you do it in SQL? Select, and then you will type count. Count is a function in SQL. And star, so you want to count all of the records, so you're typing in star, so all of the rows, basically the number of rows will be counted except the header. And type in from, and the alias that we just provided it earlier, which is taxi data, we'll call it taxi data, and simply double quote close and close this up. And what this will do is basically, and when you type in .show, this will show you the result out of that SQL query. So you will get what the MySQL would have shown you normally. So in this case, for big data, press enter, it will give you the count, right? So in our case, we have about a 10,000 number of records, basically. So we get that. Now, say we want to get a little more complex, right? So now we want to find out the total number of the total revenue that is generated, right? So the total revenue that would be generated from all of this would be the sum of the column, that is the revenue column. So if we just simply see how this is working, if we type in df.show and type in 3, so we want to see 3 records to get an idea of how the columns are working. Press and enter. So as we can see, the record that we want to refer to is the total amount, right? So this is the amount. So this particular column, we want to add up all of the values in that and finally get the value at the end of it that we would like, right? That is what we want to do. So let us just simply do that. So we know the column name that we want to refer to. So if I simply type in spark.sql and type in select sum and then type in the column name that I would like to use the sum for, which is the total amount as we saw in the column name, right? From the temporary view, which is taxi data. Close this up, press enter, and it will show you that. So actually I didn't type in show. If you simply type in show, it will show me the actual output of that, and press enter. So now as we can see, the total amount, the sum of the total amount is about $160,000 or rupees, whatever the amount is in. That is irrelevant at the moment, but yeah. So say if we want to actually do something else with this. So say we want to find out a particular fraction, right? We want to find out how much is out of this total amount that we have, the total amount that we've calculated, how much out of this is toll revenue, right? So that is also simple. Simply type in spark.sql, select sum of the toll amount. So here's the tolls amount that we have. So it's TOLLS underscore amount. So it has to be exactly that. So the total amount of toll divided by the total amount of total amount, right? So we get that, and out of the taxi data. So this will give us the value that we require.
Just a quick info guys, test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and DataFrame? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now let's continue with the session.
Type in .show after that and press enter. So as we can see, the fraction that we have is about 1.5%. So as we can see, it's about 0.015. So that is the fraction basically about with the ratio of the tolls amount and the total amount basically. And from here on out, it's basically simple SQL. So now you know you only have the only Spark aspect that is coming into it, as we had discussed earlier before. If you're coming from an RDBMS background, the only new thing that you really have to type is this spark.sql. Rest of it is basically the same. And if you want to take out the average amount for each of the trips, you can simply type in select and then type in AVG and given the column name that you want to calculate the average of. So AVG is also a function that is present in SQL by default and given like from taxi data. Close this up and type in .show. So this will give you the average amount. So the average amount for each of the trips is 16 units or $16. And if you want to get a little more complex than that, so say if you want to use the group by clause that is present within SQL, you can use that as well. So if I simply scroll up, we can see that there's a payment type, right? So the payment type and the data description is basically in categories like 1, 2s, and 3s. So all of this is there, right? So if we want to arrange particular results according to the payment type, we can do that as well as we would do in normal SQL. So if we type in spark.sql, say we want to arrange the average, say the average, any column name that we can pick up right now, the fare amount, say if you want to pick up the average fare amount that we're picking up, right? And we want to arrange it by the payment type. So the payment type could happen online, offline, like you pay cash, sometimes you use online wallets, sometimes you use cards. So basically all of those things have been mapped to particular numbers like 1s, 2s, and 3s. So that is not relevant to us right now. What we want to do is basically arrange it according to the payment type, right? So simply type in select the payment type, because you need to select the column name that you are grouping the entire query by. So the payment underscore type is the column name that you absolutely want in your result. And then simply type in the average of the fare amount. So the fare underscore amount, it has to be the exact column name that you're using. And then what you could do is simply use from taxi data, but that doesn't end there. You have to also group it by payment type. So at the end of it, simply type group by payment type, close this up, and put a dot show at the end of it, and then press enter. So that was actually an issue because we mishandled the column name. Simply type in an underscore after that because that is the actual column name, and then press enter. So as we can see, there are basically 4 payment types that we had, 1, 2, 3, and 4. So all of these could have been mapped to anything. That is not relevant to us right now, but what we know is for each payment type, we have gotten the average fare amount, right? So we can use group by as well. And if you want to go into even more complex territory, we could take a query like which hour of the day on average makes the most amount of revenue, right? So the way we would go about that is simply invoking the SQL context once again. And here we're going to be making a nested SQL statement. So if you're familiar with SQL, you would understand this. We're going to be using aliases in this. So say the first alias we would be calling h24. So h24 would be what our nested SQL query would be. And as R, we also need the average of the total amount for this. So make sure all of these names match. So we're also assigning an alias to this, which is average revenue from, and this would be the nested SQL statement. So this is also a select statement inside of this. Select R, the pickup date time. We'll just look at the column name for once. Just simply scroll up and look at the column name. What is it actually called? The pickup time. So we have the tpep underscore pickup underscore date time. So simply copy this, right? So copy this, and once we scroll down back, erase this and paste it over here. So we have our pickup date time. So this is basically the pickup time of when the trip started, right? So we actually entered our pickup time. Close this up. And refer to this as h24, which we were referring to before over here, right? So our pickup time is h24. The total amount involved in this for each particular hour, basically each particular pickup time, from taxi data. So first thing that we would do is obviously group it by h24. And order all of this. So basically ordering means sorting it, sorting all of the results by the average revenue, which is the alias for the average of the total amount. And if you don't specify the DESC right here, then it'll basically order itself in the ascending order, but we want the highest revenue that is generated. So we'll arrange it in descending order. So we get the first result first, right? And then simply close this up and type in dot show and press enter. So as we can see, the R number 22 has the highest average result, average revenue. So the 22 would basically imply the 10 p.m. mark. So in the 24-hour clock, in the 10 p.m. mark, we have the highest revenue, right? So that means 10 p.m. In this particular taxi organization's business, 10 p.m. is the most profitable. So that is basically what the average big data use case statement is. So you'll be asked by your employer to basically calculate these particular insights. So say now that you have that information, you know that you're going to be encouraging your cab drivers to be really active around that time, the 9, 10, 11 p.m. mark, because that is when you get the most revenue and the most profit out of it, right? So out of that. So as you can see, it is simply arranged in that order. 0th means the 12 a.m. mark, the 23rd means the 11 p.m. mark, and the 22 means the 10 p.m. mark. So these 3 hours are the most profitable in that particular order, right? So this is basically what you can do with Spark and the Spark SQL context. And by converting normal unstructured or semi-structured data formats to a data frame and simply running what you would run in an RDBMS system, but for big data.
Let us go over some of the companies that we see using Spark on a day-to-day basis. Amazon, Microsoft, Netflix, IBM, Yahoo. So for their big data needs, these companies are using Spark these days. And obviously, because these companies have such a large user base, they have the need, the use case for actually having tools to analyze big data.
We will be working on kind of like a real problem, crimes in Chicago, right? So the first thing that I want to talk about here is that this particular problem is taken from a certification exam. So I think an year back in the Cloudera certification exam, they asked this question, okay? Not the exact question, but very similar. So what I thought is like, I'll take a question like that, so you will also understand. In case if you're writing a certification exam, how the questions will be. So people ask. So this is how almost a question will be. And also it is a real data set, a real case study. So that also will be interesting, right? And so imagine that you're writing a exam, certification exam kind of thing, right? So they will give you a problem statement. That is how they do. They give a problem statement, then they will give you a cluster, they will give you the data, everything, and then they will ask you to solve it, right? So that is how it works. Now, the original data for this problem is actually in 4 files. You can see here. There is Chicago crimes 2001 to 4, 5 to 7, 8 to 11, and rest of the data. So the original data is approximately 2 GB. I don't want to use the original data. I want to use this last file called crimes.csv. So basically, these are the crimes reported by the Department of Police in Chicago from 2011 to 2017. And let me show you how the file looks like. Even though the file has many columns and many things, it's a very rich data set. The questions requires us to work only on 2 columns in this particular problem statement, right? But maybe you guys can use this data set to explore further, because like I said, it is a very rich data set. I'll show you what is in the data. So let me open the data set first. So the size of this file is close to 400 MB, and that is why Excel has a trouble reading the file. It will read partly. It cannot read the complete file because the size is a little bit big, right? So it's almost open. Let it open. I'll show you what is in the file. And in certification exams, what happens, in case if you're interested, we will discuss this later regarding certification. But to give you a small idea, what happens is that if you go for a Cloudera certification exam, right, on Spark or anything like that, they will give you like around 2 hours, and they will give you some 8 questions to solve, practical questions. There are no multiple choice questions. It's all hands-on, right? And ideally, if you ask me, I don't want you to write the certification exam. That's my advice, because Cloudera suggests that people should work for at least a couple of years before attempting the exam, right? Exams are tough, to be honest with you. It's not very easy. So if you directly complete the course and write the exam, you will find it very difficult to handle the questions, right? But anyway, you can probably after a year or something, if you get a chance to work, you can definitely write a certification exam. Now this is the file, Crimes in Chicago, and this has many columns. Okay, so there is an ID column, there is a case number. We are interested in this column called a date. Okay, the date column. The date column is very interesting because why it is interesting? You have like the actual date 5/3/2016. So that is like the month, day, and year, and then you have the timestamp 2340, etc. There is an AM PM as well. I don't know why it is not reading in the data set. There is an AM PM as well in the data. I don't know why it's not getting displayed. So the point I'm trying to tell you is that the date column is kind of like completely unstructured, because you have first of all backward slash for month and all, then you have column for hour, minute, second, and all. So we are interested in the date column. That's one thing. Then there is a block, IUCR code, and the second thing we are interested is this primary crime type. So each line in this file is a crime. So what kind of a crime is it? Battery, public peace violation, theft, motor vehicle theft, robbery. So we are interested in this as well. So these are the 2 columns which we are interested for our problem. There are many other columns you can explore. I will share a document which explains what is what. Don't worry, right? So, and there are many lines of data. So we have close to 1.5 million lines of data in this, which is good, right? Close to 1.5 million. So this is how the problem statement is going to look like. If you go for an exam, this is how the problem statement is going to look like. So they will ask, choose language of your choice, Python or Scala. So it doesn't matter which language you are using. The data is available under certain location. They will give you the location for the data, and they will say you can check the properties of the file by running a command, and they will say the structure of the data is like this. These are the columns you have in the data. File format is text file, delimiter is comma, and this is the problem statement. Get monthly count of prime crime type sorted by month in ascending order and number of crimes in descending order. I will explain the problem statement later in detail, but that is the problem statement. Then they will say store the result in your HDFS path. They will give a location where you have to store the output of your program. The output file format has to be text. Output columns, very important. They will say that in the output, they want 3 columns. You need a month column that is in YYYYMM format, crime count, crime type, and the output delimiter has to be tab. So this is your entire problem statement. Now I know that for people who are very new to this, it will take at least half an hour to understand the problem, because it's not straightforward, right? If you sit for an exam, it is not straightforward. It's very confusing actually, right? And you will have trouble understanding the problem itself. But I will explain the problem. What I wrote here is not part of the business problem. This is something I wrote to analyze it. Don't worry about this, right? But this is something I wrote myself. This is actually part of the business problem. Okay, fine. So now let us see what they're asking, right? So, okay. So From this data set, what I did is that I just took some sample data to make you understand. First of all, this is the problem statement. Get monthly count of primary crime type sorted by month in ascending and number of crimes per type in descending order. Okay, fine. Output columns, month has to be in YYYYMM format. So our first challenge is we need to get the month in this format, YYYYMM. So I have taken a simple example here. So imagine from the data set, you extracted the data like this. For example, so this is how you're going to extract. So let me just write it so it's easy for you to understand. Control C, Control V. And again, this one, Control X, Control V. So this is 2007, 07. Just hold on for a moment. I'll explain what it is, okay? Don't worry. 2007-03 X 2007-02. So your first challenge is that even without understanding the business problem, you can understand that they are looking for month in YYYYMM format. This is your first challenge because the data looks like this. If you read the data is like this. It has, let's say, the month, which is, let's say, 05 slash the day slash, let's say, 2007. Then there is a hour, minute, second. So the data, and then there is an AM, PM. So the column value is like this, right? I don't want this. I want to convert this in YYYYMM format, right? That is your first challenge. And imagine somehow you are able to do it. Okay. So what you will be doing, from each record, from each line of your CSV file, you will extract the month and you will somehow calculate the number of crimes happened in that month. So it's sort of like a word count. So let us say you're talking about 2007 January. So in 2007 January, so this is 2007 January, right? There can be a crime type called battery, and you collect each battery crime, and then you do sort of like a word count with the month as the key, battery as the value. You figured out that there are like 300 crimes related to battery, imagine, right? And then again in 2007 January, you figured out that there are 200 theft crimes. Okay, fine. Then you land in 2007 July. In July, 100 theft is there, 50 robbery is there. And then you land in March. In March, 300 robbery, 400 theft. Then you land in February. In February, 100 rape, 500 theft. So your first challenge is, from the original data, you have to get only the year and month, okay, and the number of crimes happened. Once you get it, now your problem is, the business problem says, you have to sort the data by month in ascending order. Okay, what do you mean by month in ascending order? See, if you look at here, it's fine because you are having January. After January, you are getting July. It's okay. But after July, you are getting March. This is not good. After March, you are getting February. No. So I want like January, February, March, July. First challenge. The first challenge is you have to pick up only the year, month, and also year. So because there is multiple years of data, so after 2007 you should get 2008, and in 2008 Jan should come first, right? Because that is how people want to read the data, right? If somebody is looking at crime data, they want to read it in an order, right? Yearly order, monthly order. So first problem for us is that we have to sort it based on year and month. We are not done. Then they say sorted by month in ascending order and number of crimes per type in descending order. So what does this mean? So if this is your data, I want the output like this. Again, 2007, 01, this, and again here, 2007, 02, this, here, 2007, 03, I think this, 2007, 07, this.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD, B. DataFrame, C. Dataset, D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this data set, the output has to come like this. That too, it has to be tab delimited. I'll tell you how the output will look like. So it's easy for you to understand. So I'm going to use what? Tab as the delimiter. That is my problem. Now I don't want to use tab, but that's what the problem says. Battery 300, theft 200. This is your final output. Meaning, if you look at the final output, what you see is that, first of all, look at the first column only. The first column is sorted in ascending order: January, February, March, July. And within each month, the number of crimes are sorted descending order. Look at January. Battery comes first because 300, then 200. Look at February. Theft come first because 500, then 100. March. Theft come first because 400, then 300. But the original data is not like this. That is what I want to tell you. If you look at the original data for March, this is March. In March, the original data says robbery is coming first, then theft is coming. Line by line if you read. Now I don't want that. I want theft to come first within March because top crimes are theft. Why? Because anybody who want to look at crimes, they want to see like this. If I'm looking at January, I want to see the top number first, right? Battery is number 1. I don't want to see the bottom crimes. I want to see the most happened type of crime. So your final output of our today's problem should have 3 columns. They should be tab delimited, and the first column should be month, second should be crime type, third should be number of that type of crime. Month has to be sorted ascending. Within each month, crime type descending. So I'm going to go to my lab. I'm going to connect with the lab. Everything can be done from here. It's very easy, very straightforward. And I have already uploaded the data in Hadoop on my cloud lab. There is a folder called Raghu. Within that folder, we have the data. So the data is already uploaded. And I want to start the Spark shell. So the solution is here. And since we are dealing with kind of like, how do I say, a slightly bigger data set, what I want to do is I want to start the Spark shell, and I have to say master yarn. So normally you do it in the local mode, but the problem with local mode is like you're getting single executor, the amount of memory is less. I don't want to do that. So I'm going to say master yarn. I'm going to ask for 2 executors, and each executor will have 1 GB RAM. So total you get 2 GB RAM and 2 cores. Okay, so let's start it. Let's see whether it gives us resources. First of all, looks like we are going to get resources. And CloudX Lab is running the Spark version 2.1.1. That's fine with me. Any 2. Version is okay with me. They are running 2.1.1. We got the resources. Spark started. See, the version is 2.1.1. And what I'm going to do, the first step is that I'm going to read the data. Anyway, that's required, right? And when you're creating RDDs, do not say A, B, C, D. Give a name for the RDD. So I have given a name called crime data. Crime data is the name of my RDD. So if anybody look at my code, they can understand what I'm doing, right? So this basically contains the crime data. And I'm going to say I'm reading this file called crimes.csv. Now let's see whether it is able to read the file, I can do a crime data doc take 5, and I can say for each println. So take will show you, take is an action. It will show you the first 5 lines. I'm saying for each println, so it will print it line by line. Okay, so we are able to print. So the data, we are able to read the data. There is only one problem. It is also reading the header. This is the header, So the data contains header, and our RDD is also reading the header. I really don't want the header. I will show you how to get rid of the header. Okay. But let's also verify how many lines of data we are having. Crime data dot count. Okay. So when I call an action called count, I can see that we have around 1.4 million lines of data, which is nice, So, okay, so we have data. The first challenge is to remove the header. If I do a crime data dot first, I can see that the first element of my RDD is header, right? I don't want the header. I want to get rid of it. See, there is things like FBI code and all. It's it's proper data, community area, FBI code, all these things are there. Okay, so how do you get rid of header? It's rather easy. So you can create a variable called a header, first of all. So I'm going to create a Scala variable called a header by reading the first line of the RDD. So this variable called header will have a string value that is nothing but the first line of my data, header data. And now I can use a filter to remove this header from the original RDD. Let me show you. I'm going to create a new RDD that is called crime data without header. So you see the name of the RDD. I'm giving sensible names. I'm not saying A, B, C, D. This will even help me if I want to troubleshoot my program. If I look at this RDD, I know this RDD is the guy without the header because I have named it as crime data without header. So I'm going to say that crime data dot filter. I'm going to filter, and usually you say X, right? So normally when you write an anonymous function, you will say X, then rocket symbol. But here I'm saying criminal record. So each line is what? A criminal record. I can very well use X, but this will be more appealing. So if somebody look at my program, it's easy for them to read. So I'm going to say that take every line. I'm going to filter the data, take every line, and I want all the lines which are not equal to header or not matching with the header. So what Spark will do, it will run a filter transformation. It's going to compare each line with header, and it's going to keep only those lines, which are not matching with the header variable. So basically you will eliminate the header. Now let's look at the RDD, crime data without header. So if I look at this RDD and I will say I want to take 5 dot for each println. Yes. So the new RDD called crime data without header has, this thing gone. The header is gone. We are happy. So we have only the data now. So that is your first step. So Monangi says how it will know that it is header. It doesn't know. I've stored it in a variable, right? Monangi, see, look at here. I'm storing it in a Scala variable. So header is just the name of the variable. It can be Raghu very well. It can be anything. So I'm matching the content of this variable. Header is a variable, Scala variable. Okay. I'm matching. So when I say not equal to header, this header that you read here is this variable. Okay, and this variable contains this data. So basically it will match every line with this data. That is what is happening. Okay, so we got an RDD called crime data without header. So what is our challenge now? The challenge now is I want to extract the date column. I want to extract the date column. So when I say crime data.
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Without header dot first. So I'm just typing crime data without header dot first. So you are getting one line of data from the original data. And look at the date field. This is the date field. So it says 3rd May 2016 backward slash. Then you have a space. Then you have the time with colon as delimiter. Then you have a space. Then you have AM PM. So I don't want all of this. I just want only the YY MM from this, right? So that is our requirement. The problem statement says, give me YY MM. So what we are going to do, we are first going to read this data and store it in a variable. So I'm going to say crime data without header dot first. That is nothing but the first line of your data. You're going to read it and store it in a variable called rec. What is rec? The rec is nothing but a string. It's not an RDD. It's not anything like that. Rec is nothing but a simple Scala string, but that contains one line of your data. It has one line of your data. Now, usually if you want to develop a logic, what you do is that you take one line of the data and develop the logic. Then you use map transformation to apply to the whole RDD. Do not directly work on the RDD because you know the RDD is pretty big in this example, right? So what I did, I took one line of data and I'm going to develop a logic on this line of data, right? And what is the logic? So you should also understand what the logic will do, right? So my logic says that from this data, so I will definitely extract what the YYMM part, then I will get the crime type. I will also get the crime count. End of the day, I will do sort of like a word count. I will get a crime count also. So if this is your data, 2007, you have in 2007, 01, and then you have, let's say, battery, and let's say 300. Then you have, let's say, theft, and let's say 200. I want to convert this into this format. So how do you know that this is the format you have to convert to? It has to come with experience. You may be wondering, okay, why are you converting this into this format, right? How do you differentiate it is string or RDD? If you look at here, it will show you. For example, the name of my variable is rec. If I type rec, just rec, it will say it's a string. It will simply show you it is a string. But crime data, we have created crime data. If I just say crime data, it will say it's an RDD. So if you simply type the name of the variable, it will show you whether it is string or it is an RDD, right? It's very straightforward, right? And how do you technically know if you call an action? If you call an action on the RDD, the output is not an RDD. That's the rule. Any action you call an RDD, the output will be an integer or a string or anything that you can save it, usually a string, right? Okay, so now if you look at this, my requirement now is, if this is the data you have, let's say in January month, you get battery 300, theft 200, etc., etc., right? If this is what you are getting, I want to convert this into a tuple format, this format. The tuple will basically have your year and month, okay? So if this is your data, what will happen is that I want to convert this data into a tuple format. And in the tuple, I will have the key as your 2007-01, and the values will be sort of like this and this, right? This is what I want to do first. So let us try to attempt this first so that you can understand how it is done. Okay, so I'm back here. And if you remember, we have a variable called a rec, and a rec has one line of data. Okay, so what do you want to do with one line of data? See, the date is from the date column, I want to extract only the date. You see the date column? What is in the date column? This is the whole date column, right? I don't want this whole thing. First of all, I want only this part. So how do you get this part? It's very easy. Let me show you. First of all, I'm going to say that I want to split this string based on comma, because you know this whole string is having comma as a delimiter. So I'm going to create an array called R, where I will store this whole string divided by comma. Why am I creating an array? So that I can access individual elements. So now I have an array, and in the array, I have all these individual elements. Okay. And the name of the array is what? R. The name can be anything. From the array, look at what I'm doing. From the array, I'm accessing the fourth element. What is the fourth element? First element, second element, third element, fourth element. This is the fourth element. From the array, I'm accessing the fourth element. Again, from this, I'm splitting it using space. So if I have to show you, if I get only this R3, you will get the whole thing, you know, the date, the time, the AM, PM. I don't want this, right? So what I do is that I say further split it using space. So when you split it using space, this will be one, this will be another one, this will be another one. And then you say, give me only the first element. That is the date part. If I hit enter, this variable called D will have only the date part. Okay, so what you do, you say that I want the fourth element in the array. From that element, again, I want to split it using space. From that, I want the first element. So basically, you get only the date in this format, 5/3/2016. But what is your problem? You are not happy because I don't want the date in this format. I want the date in YYYYMM format. What is this format? So this data has to be like 2016-03. But my format is difficult now. It is like 5/3/2016. Right? So I need to convert this data now into 2016-03. How do I do it? It's rather simple. All I need to do is this. So have a look at what I'm trying to do. I'm going to say that I want to split the data using backward slash. So when you split using backward slash, what will happen? You get individual elements. Then I want the third element. So what this will give you? This will give you only 2016, right? And if I say I want d dot split, okay, and then again you say backward slash, and the month will be the 0th guy, this will give you 5. So we are doing a lot of slicing and dicing, I understand, and that is required. So from this entire date column, I split it using forward slash, and I'm asking, give me the last part, that is a year. Again, I split it using forward slash, give me the first part, that is a month. If I do it in a single line and concatenate it, you will have the complete thing. So I will say, give me the last part plus give me the first part, concatenate it, you have 2016-05. So look at this whole piece of thing. All we did is some slicing and dicing. But end of the day, the data we extracted first, only the, what you say, month, day, year part, right? And from this, we extracted the year and month and concatenated so that we have 2016-05. So this is the logic to get YYYYMM from the data. That is your first task, right? I hope all of you understand this because it's not that difficult. It is only basic slicing and dicing. However, we are not done because we are extracting only the date. We also want the crime type, battery, robbery, or whatever it is. So what I want is that I want the data in this format. So what am I trying to do? This M will have your, what you say, month. The variable called M which we just created, will have your month. I want the data in this format where I need a key value pair. So what I'm doing here is that I'm converting m to integer, then r of 6. What is r? R is our first array where the whole data is, and the seventh element in our data is crime type. So that is like battery, comma 1. Why am I representing my data like this? Because I want to do word count. See, if battery is repeating in 2016 May, I can easily do a word count, right? Otherwise, how do you know how many battery crimes happened in May? If I want to get a total count of battery crimes in May, I need to create a key like this. This key is kind of like a composite key. It has month and crime type, but for each record, I'm calling a 1. So if I do a word count on this, I can see if it is battery, if it is repeating 3 times, it will do a word count. I can see in 2016 May, 3 battery crimes have occurred. This is your half part of the problem. So half part of the problem is doing this, and I can do the whole thing in a single line. That's what I want to show you. So once you develop your logic, ideally you should write the whole thing in a single line. I'll show you R, because not R, I'll show you rec. So we first start with splitting our rec based on comma. Then from there, we get the fourth element, split it using space, extract the first element. This will give you the date part. From there, again, I concatenate to get, let's say 2016 May. Finally, I represent like 2016 May battery, comma 1. This is your first task, or I can say half of the task. 0 refers to first element. So when you are accessing elements in the array, remember we had this Scala collection class, arrays, list, and all. So 0 basically refers first element. Okay. And also it sometimes I guess, in my opinion, you might have to run it by yourself to understand it. Well, I can show you this, but I'll share the piece of code. Probably you might have to sit for some time to run it step by step and understand what it is, right? So right now we have a variable called a t, and if you look at how I created this t, I will get the output in this format. But we are playing with only one line of data. We are not playing with the RDD. So I want to apply this logic to my RDD. So how do I apply my logic to RDD? Very simple. I can call a map transformation. So have a look at what I'm going to do. I'm going to apply the same logic to my RDD. So I'm going to create a new RDD called criminal records with month and type. And I say take crime data without header dot map, and I paste this whole thing. So you see, this is the effect of map transformation. The logic to extract the tuple you have written, but that will extract only from one line. I want to convert each line of my data to this format. So I call the map transformation, and within the map transformation, I type this entire logic, right? So what could have happened is that Spark could have created a new RDD called criminal records with month and type. Let's check out this RDD. And if I say dot take 5 dot for each println, very well. So now look at the data. The whole data is transformed into this. Now do you understand? Look at only battery. How many times battery is repeating in this thing? 3 times, right? I can easily do a word count program here, right? Because this will become my key, and 1 is the value. So if I want to know how many battery crimes happened in 2016 May, or any month for that matter, I do a simple reduce by key, I will get it. I hope you understand the logic behind that. And that is exactly what I'm going to do. I'm gonna create one more RDD. It's gonna be crime count per month per type. So I'm gonna say criminal records with month and type reduced by key. Instead of X comma Y, I wrote total comma value, total plus value. So basically it does sort of like word count. So we will get a new RDD. And if I check this guy dot, let's say, take 10, I know that this program looks a bit complicated, but you guys asked for me, right? You were crying yesterday, give me production program, give me production program. Now you suffer. Production programs are like this, nobody understand, right? People are like, okay, you are not showing better programs, you're always showing basic programs. Now, if you're not able to understand, I can't help. I can help little bit, but there is no other shortcut, right? You have to sit and read and understand. Production programs are like this only. It's not easy to interpret. It's not easy to understand. See, I can't do both, right? Either I can show you all simple programs, right? But if you say that, okay, I want to see a bit complicated program, the program will have a bit, logic into it, right? And not everybody will be able to catch it for the first time. So what I advise normally is that you take the data set, you take the solution, you break it down, step by step you run, you see what is happening. That is the only way to understand these kind of programs, right? Anyway, we have reached in a situation where now how the data looks like. So I will always tell my participants, before you write the code, you should see how the data looks like. So now the challenge is, I have the data in sort of like a key value pair. Okay. And the key is a combination of what you say, the month and crime type. The value is how many crime happened in that month. For example, in 2012, April, 62 gambling crimes have happened. Or in 2004, July, 31 liquor law violations have happened. But now is the real challenge. The real challenge is, now I have to sort this data based on month in ascending order. You see, it is not at all sorted. So my first challenge is, I want to sort the data based on month in ascending order. At the same time, I want to sort based on number of crimes in descending order. Now, let me tell you one more thing. You may be thinking that it is easy. Okay, you do a sort by key, everything will work. Yeah, I understand. So if I try a sort by key, let me show you what will happen. I'm just going to say sort by key. Okay. Or probably we have to store it as something, right? So this is not part of the program. Sort by key. If I say a dot take 10 println, do you see what has happened? The data is sorted now, because you can see that in 2012 January is there. These are all January crimes. Then February will come. But what is the problem now? Tell me. What is the problem now? I applied a sort by key. Did I get my final answer? Is this my final answer? If not, what is the problem here? Because the type of crime I want in December. So in 2012 January, I should first get assault, because not assault, battery, because most number of crime is battery. So this should come first. Then assault should come. Then probably criminal damage should come, right? But the problem with sort by key is that, so the problem with sort by key is that it's sorted based on your key. The key was what? The date, and then your and also you see it is sorting alphabetically. Arson will come first, battery A, B, C, D, G. So your key has two parts. There is a date and crime type. What it is doing in January, it is sorting based on A, B, C, D. Right? Now, even if you use sort by, this will not fix. Because the problem is here, when you say sort, you can sort either key or value, or only one column. And that is my real problem. So if I say sort by key, it will sort based on this. Or I can say sort by value based on this. So one way I have to do it is that I can store this as an RDD. Again, I can pick up the second part and sort it, but that will be very complicated. So I can solve this problem using sort by key again, but that logic is slightly complicated. I will explain that to you. We are going to use sort by key only for this problem. Let me see if I have given it somewhere, the explanation. Yeah, probably I will give you a fresh explanation. So let me pick up some data so I can explain it to you. Probably I will pick up 4 lines of data. So let's say you are taking only these 4 lines of data, okay? And the final output has to be in a different way. You know that, right? Now I'm going to use a logic to sort these guys. So this is my data. This is my original data after sorting, right? And you see it is like 2001, then it comes arson and 39, then it comes assault, then battery, then burglary. So no, I don't want it like this. I have written a logic. I will show you that. So we are trying to explore the final solution, right? So you see, I have written it here a little bit. The data looks like now you have a month column, and then there is a crime type like weapons violation, and then there is a count. This is how the data looks like, right? And what we are going to do is we are going to convert this into a different format so we can, in fact, sort the data. So as an example, if you look at this code, right? So what I'm doing here is that I'm using sort by key for sure. I'm going to sort my data in sort by key. But like I said, if you simply do a sort by key, you will not get the desired output, right? So what I'm going to do here is I'm going to do a map transformation on the data. So let me just copy this whole thing so you'll understand what I'm doing. Yeah. So, sorry, solution, where is it? Right. So the original data looks like this now. So you have a key and a value, right? So in this data, what you need to understand is that, just put it like this. What is the key here? This is the key. And this is the value in our terms, or I would like to call it as a tuple, right? And what am I doing? I'm applying a map transformation. I'm saying that take every record. When I say every record, this whole thing is a record, okay? And I want to convert that into a specific format. Now this looks a bit confusing, but this is the format I want to convert it. So it says rec dot underscore one dot underscore one. So what do you really mean by this? When you say rec dot underscore one, it basically means the key. This is the whole key. Within that, again, you're saying dot underscore one, which basically means this part, right? So this is going to be the key. So let us write it so we can understand. So I'm going to take the first row of data. Okay. I'm going to take the first row of data, and rec dot underscore one is nothing but my key. Within that, again, dot underscore one is this part. I'm going to take this part, Control C, Control V. So this is this part, comma, negative value of rec dot underscore two. What is rec dot underscore two? That is nothing but this 39. Negative value of 39. Why? I will tell you. So I will convert this into negative, let's say 39. Okay. Then what I want to do? Comma. So this comma, rec dot underscore one dot underscore one again comes here. So which is nothing but your 2012-01. And then I put a tab. So you see there is a tab here. And then what happens? You have rec dot underscore two. That is nothing but 39. This is 39. Again, I put a tab. Again, I say rec dot underscore one dot underscore two. That's nothing but arson in the first case. So my point is, this line is getting converted into this format. So what you need to understand about this format is that this is one part. It's like a key value pair. Then there is a tab. Then there is the crime number. Then there is a tab, and then there is arson. Right. So let me keep it separate so it's easy for us to read it. And also, I'll remove these commas and make it a more nicer to read it. Right. So this is one line. Similarly, all 4 lines will get converted. Right. So I think it is very similar. Right. So I can just do a copy paste. Control C, V, V, V. So this is going to be 2012. All are 01. Right. And the second one, the number is going to be what? 1294. Okay. And this is also going to be 1294. And the type is what? Assault. Okay. And the third one is going to be what? Negative 4307. Okay. And also going to be 4307. Okay. And this is what? Not arson. This is what? Battery. The last one is 1757. Okay. And here it is going to be 1757. And this is what kind of a crime? Burglary. So your original data, which was in this format, gets converted into this format. This is first thing you need to understand. Did you understand how did I convert it? It's very simple because you are just accessing the elements. I'm just saying that take every line of data and I need a key value pair like this, where the key is going to be the year, the value is going to be the negative count. I'll tell you why it is negative, comma, again I will put the year. Okay, so this whole thing is what you see here, this first part.
Just a quick info guys, test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and DataFrame? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now let's continue with the session.
Then I put a tab and then I say give me the second part of the data, that is the crime number 39. Then I'll say put a tab, again I need a tab, and give me the crime type, that is arson. So this data gets converted into this data. Now let me tell you why I did this negative number. There is a logic behind it. Okay, what is the logic? If you look at my solution, where is the solution? Yes. Can you tell me what will happen if I do a sort by key now on the above data, on this data set, Okay, by the way, in this data set, what is the key and what is the value? So this is going to be the key and this is going to be the value. And these are just extra elements. These are not key or value or anything. This is what you need to concentrate. And this part is the key. This part is the value. If I do a sort by key, what is going to happen is that definitely it will start like January, February, March. The year will be sorted in ascending order, right? Within each year, what do you think will happen? These are negative numbers. So when you sort negative numbers in ascending order, is negative 39 bigger or 1294 bigger? What do you think? Which one is bigger? Negative 39 or negative 1294? Which one is bigger? 39 is bigger. 39 is bigger, right? When you talk about negative numbers, 39 is bigger and this is smaller and you are sorting in ascending order. So what will happen? Naturally, this line will come first. If you do a sort by key, this line will come first. Why this line is coming first? Because the smallest number here is negative 4307. Negative 4307. This is the key. You are touching only the key. Already you sorted based on January. Within January, you have 4 values and the lowest value is minus 4307. What will be the next candidate? Next candidate will be this guy because that is the next smallest one. What will be the next candidate? It will be this. What will be the next candidate? It will be this. Do you see what has happened now? What has really happened is that using the negative technique, you did ascending, descending sorting in the same piece of code, right? And now what I can do in the final output, I don't need the key. If you understood this much, what I can do is in the final output, I will say, I don't want the key. Yeah, I don't want the key. I was using the key for sorting. So if I copy paste this in the final output, okay, the key will be removed because you can omit to remove the key. And does this look like your expected output? Yes, it is. The year and month is sorted in ascending within each descending order for your crime type. I know it's a hard to understand, but this is what we are doing in the piece of code, right? So I used a negative number only for sorting so that I can retain the corresponding values. So when you sort, the remaining data also gets sorted, right? So when I say for negative 437, after a tab, I have a positive 4307, which is getting kept here. So naturally, the other part is getting sorted as well, right? So what we did, I'll just repeat once more, but I don't think even if I repeat, if you didn't catch it, you may understand. The only way to understand this is to run your code, right? I'll give you time to, I'll give you the answer. You can run the code and all, right? So I'll explain this once more. This is your original data. The original data gets converted in this format. And I think that part you have already understood, right? So now your data looks like this, right? And the data has a key, which is a combination of month and negative value of crime count. The value, again, that is a month, then a tab, crime count, and crime type. So that is how the data looks like now. And what I do, I run a sort by key on this data. So when I run a sort by key, since the key is a composite key, the key contains two parts. It's first gonna sort based on the month and year. So 2012, Jan, Feb, March, or 13, like that it'll come. Within 2012, it's gonna identify that there are 4 values. And sort by key, by default, since it does descending, it's gonna choose the smallest value first. So naturally, negative 4307 is going to come first. Automatically, since your data also contain the positive value, this guy will automatically become the first element here. And then 1715, 1294, 39. So your sort by key output is going to look like this. And then I can say, I want to avoid the key because the use of the key was only for sorting. I want the remaining data, you get the output. Now let's do this in the code as well so you can understand. So where are we? Yeah, so we are here. Crime count per month per type. So the data is like this. Now the whole thing I wrote like a single line. There is no other way. But if I do this, you will understand. What I'm doing here is that I take the data. I will run a map transformation to extract the data in the format we have given. Then I do a sort by key. And after that, I will say I want only the second element. So I'm basically removing the key part from here. So now if you take the final RDD and do a take 10 and say for each println, see, now this is the expected final output. 2012 January, the most cases are theft, then battery, then narcotics. So you can see that the month is ascending and crime type is descending. Also the delimiter is tab. So this is the problem with certification questions. They want everything to be in the proper order. Now, if you think about the problem statement, you see how do you productionize a Spark program? So let me just delete some of these things. These might be required. So the next topic is how to productionize Spark programs. Or in a very simple way, if you are a Spark developer, how do you write Spark programs? Will you actually take the Spark shell to develop this, right? For example, if you are a Spark developer working in a company, how do you write a Spark program? And how do you test it? Then how do you execute it? So the first thing that you need to understand is that If you are working as a Spark developer, one thing you can do is definitely you can look at the Spark shell. But that again is kind of like, I don't know. See, you have to type line by line and then see and So usually people prefer an IDE. So if you are a developer, and the first thing is that so let me write the things that you need to do. You have to download, let's say, IntelliJ. Now you can do this on Eclipse as well, but when it comes to Scala, IntelliJ is mostly preferred for Spark programs. So first step you need to do is that you have to download this IDE called IntelliJ. How do you download it? Very simple. You go to Google and just search for IntelliJ. You will land on the official website of IntelliJ, right? IntelliJ has a paid version and a free version. So if you click on the download link, it will show you the ultimate version and the community version. Ultimate version is the paid one. Don't download it. Community version is the free one. Just click on download. It will download, install it, and you will be having IntelliJ. Now I have already installed IntelliJ and I can show you that just to do this. Now, surprisingly, many of you will know this, but I see in every class, there will be some participants who are not aware of this. In order to run a Spark program, you don't have to install Spark. I don't know how many of you get this idea. So I am going to run a Spark program on my Windows laptop. Okay, I will run it and show you practically. I will run a Spark program end to end on my Windows laptop. And I will not install Spark. I don't need Spark at all. Well, Spark is required, but my point is you don't have to download and install Spark. Why? Because you need to use something called build tools. Now, see, if you're writing a Spark program, then you will be definitely using Spark libraries, right? So Spark has a lot of libraries. So if you're looking at this Spark context, SC, they are all part of your Spark core library, right? So usually what we do is that we use something called a build tool. There is something called a build tool. So step number one is you download IntelliJ. Once you download, you start it. It will look something very similar to this. Step number two is download the build tool called SBT. There are many build tools. If you talk about them, there is something called Maven, there is Ant, there is Gradle, there is SBT. There are many build tools. What is the purpose of a build tool? A build tool can basically take a requirement from you. So I'm going to use something called SBT. I will download and install SBT on my Windows laptop. Okay. Once I download and install SBT on my Windows laptop, I can go to SBT and tell SBT that, boss, I have a Spark program to compile. Okay, I need Spark libraries. This SBT will go to internet and download all the required libraries to compile my program. And it can do that for any open source project. So build tools are very popular. So for Spark programs, the most popular build tool is SBT or Maven, whatever you call it, right? So how do you install SBT? It's again very easy. You just go to Google, you say download SBT, and the first link is SBT download. It's pretty straightforward. You can see a .msi file for Windows. Click on it. It will download it. You will get a file. Next, SBT will be installed. I will show you how to build the program and all. Don't worry. Okay. But you need to download and install it. SBT actually stands for a Scala build tool. And it is not only for Spark. Any Scala project you can build using SBT. Spark is one of the frameworks which is written using Scala, right? There are many other frameworks. In all of them, SBT is a very popular build tool. So once you install SBT, SBT is a command line tool. There is no graphical user interface. There is no GUI or anything. So what you can do, you can open the command line, Windows command line, CMD, and just to check whether SBT is installed properly, you can type a command called sbt about. So there is a command called sbt about. If you run this command, let me run this. It will show you so many things. Don't worry. So it will show you so many things. Finally, it will show like this. This is SBT 0.13.16. So it is just showing you the version of SBT. I have a slightly older version. If you guys are downloading now, you may get a latest version. That's perfectly fine. But this is how you test whether SBT is properly installed. Just run the command SBT about. It should simply show you the version. That means everything is working fine. You're happy, right? Okay, so these are the prerequisites. You need to have IntelliJ, you need to have SBT. For Python, I don't know what is a build tool. Honestly, I don't know. I have never built a Python program, so I don't know. You need to check. There might be a build tool, or probably they are using some third-party tools. I never got an opportunity to build a Python program, right? Full name of SBT is Scala build tool. Scala build tool. Now the problem is you need some program, right? So once you download IntelliJ and then download and install SBT, you are ready to productionize your Spark program. So naturally your question will be that, how do I productionize my Spark program? So what do we do normally is that we will write a Spark program and test it locally. Spark can very well read from your Windows laptop or Linux or Mac or anything. So usually what I do is that if I have to develop a program, I'll take a sample data, copy to my C drive or D drive. I'll write everything inside IntelliJ. I'll read the data, write all the transformations, run it. I can even see the output on my IntelliJ. Right? Everything can be displayed in IntelliJ. So if everything works for me, I say, okay, everything is nice. What I will do, I'll just change the location of the data, compile it, and then run it in the Spark cluster. So end of the day, if you write a program, you have to compile and produce a jar file, jar file. In MapReduce, so MapReduce programs, I think you created a jar file, am I correct? You compiled it and created a jar file, right? And then that jar file you are running, correct? Yeah, very similar to that. Here also, you need to compile and create a jar file. Let me also show you the data. So I have written a simple program. If you look at the code, where is the data? I think it is in C data. So retail DB, order items. Yeah, so you are reading this file. See, there is a file called a part 00000. So this is nothing. This is basically some transaction data that we have. And let me also open the code and see what we are reading. So 1 and 4. So if you look at this data, this is the order ID. The second column is the order ID. Can you see? 1, 2, and the third and after that, the fourth and the fifth column is the amount. 299.98 is the amount. So if I look at the first line of data, the order ID is 1. Okay, that is the second value. And the amount is 299. If you look at the remaining 3 lines, what is order ID? 2. So under same order ID, there are 3 transactions. Okay, because in this line, the order ID is 2, amount is 199. Here, order ID is 2, amount is 50. Here, order ID is 2, amount is 99. So basically, you want to calculate total revenue per order ID. It's again like a word count program. So you will be taking this 2 as a key and this thing as a value. And then you do a reduce by key, you get the output. So I'm not really interested in the program. Rather than the program, I want to show you how to productionize it, right? So I have written a program. Now, when you write a Spark program, what are the things that you need to take care? First of all, who can tell me what is Spark context? Who can tell me? What is Spark context? Okay, Spark context is not the driver program. Okay, it's part of the driver program probably. It's part of the driver program. Let me ask you this question. In the Spark session, you have Spark context. Why do you need it? So the new way is Spark session, right? Even in Spark session, you get Spark context object. Why do you need it? So the answer is Spark context is the object which will communicate with your cluster manager, like yarn, right? Spark context, remember, the driver will communicate with cluster manager using Spark context object. So Spark context is not the driver, it's part of the driver. But when the driver want to talk to executors, driver want to talk to yarn, it uses this Spark context object. And normally what happens when you start the Spark shell, the Spark context will be available as SC. That is why you say sc.text file and all. So when you want to read something, you will say sc.text file, right? So if you are using a shell, the Spark shell, the Spark context object will be automatically created for you. But when you're developing a program, you need to create your own Spark context object. That is a rule. So in a shell, it will automatically appear. In a program, you need to create it. It's a class. You can basically call and instantiate. Basically, it is a class. You just create an object out of it. That is all you need to do. Also, you need to create something called Spark configuration object. What is this Spark configuration object? So I told you that if you're writing a Spark program, you can put all your configurations in the program. For example, whether my program should run in local mode or yarn mode. What is the name of my program? In what port number it should run? How many executors it need? How many processor cores it need? All these settings, okay, settings and configuration, you can add in the configuration object. And using the configuration object, you will initialize your Spark context object. So what the steps are like this. First, you create a Spark configuration object, and using the Spark configuration object, you initialize the Spark context object. This is what is going to happen. So when you write the program, I'll show you how this can be done. So you can import the Spark libraries, and all of this are available as libraries and classes. You just need to say new for creating an object out of a class. So first you will create a Spark configuration object, add some properties to that, and using the Spark configuration object, you will initialize your Spark context object. Once you have the Spark context object, remaining code is same as you know. If you observe a MapReduce program, it is also very similar. I don't know how many of you have seen a MapReduce program. In the MapReduce program, in the driver part of the code, you will create a conf variable, configuration, right? And under that conf variable, you will call the mapper class, reducer class, everything. So the idea is same, but we have to manually create these things inside our Spark program. That is the prerequisite. Once you create your Spark context object inside the program, then you can read the data, write it. Now, like Monangi was rightly pointing out, there is another thing called Spark session. Spark session is the new way of accessing, it is a new entry point to Spark's functionality. There is something called Spark session object. We will talk about that more in the Spark SQL class. But in the modern programs or the latest programs, when you look at the program, they will create something called Spark session and then initialize Spark context from the Spark session. Either way, you can do it. It's up to you. Without Spark context object, nothing will work basically in Spark, because that is the object for communication, right? So driver and executors, driver and cluster manager, they talk using this object.
Now let us look at the career opportunities in Spark. So isn't Spark doing a great job?
Also, it is a fact that Apache Spark developers are among the highest paid programmers in the Hadoop framework as compared to 10 other Hadoop development tools. As per a recent survey by O'Reilly Media, it was evident that having Apache Spark skills under your belt can give you a hike in salary, and also mastering Scala programming can give you a further jump in your annual salary. This is the best time to start your career in Spark.
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. So guys, we have come to the end of the session. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Thanks for watching.